Hello everyone, welcome to BYJU'S exam prep, most comprehensive app for all exams. How are you guys? कैसे हैं आप लोग? Now the complete revision of what circuit theory or what that is network, and this session is important for what electronics, electrical and instrumentation branch. And here we are going to discuss what 30 most important questions with every concept. Okay, and this is a concept through numericals. So first of all, share the link of this session, right? And then Mani, how are you? Very good evening everyone, please join the session. Now this is a complete network, right? And we will discuss here KCL, KVL, mesh analysis, nodal analysis, transient, first order, second order, resonance, and what two-port network, and some questions on steady state analysis of sinusoidal signal. Okay, so I am fine, that sound quality, picture quality, everything is fine. तो चलिए आप बुला लीजिए सबको, प्लीज शेयर द लिंक ऑफ दिस सेशन. एक बार जरा अपनी अटेंडेंस मार्क कर दीजिए, लाइक द सेशन एंड सब्सक्राइब द चैनल. ओके, अब देखिए जरा, दिस इज माय इंट्रोडक्शन. माई सेल्फ संजय राठी, 20+ years of teaching experience in the field of competitive exams like ESE, GATE and PSU. These are my ranks: AIR 16 in ESE 2005 and AIR 21 in ESE 2008, and I have mentored more than 1 lakh students for these competitive exams. Or these are my area: network, digital, control, EDC, analog and advanced electronics. Okay, now this subject, that network, right, every year around 8 to 12 marks, 1 marks question, 2 marks question, numerical based question, right? And in MSQ you may get what theoretical question, but mainly what numerical based question. And which topics are important here? We have questions from mesh analysis, nodal analysis, that is basics, and then what theorems, Thevenin's, Norton's, maximum power transfer theorem, then what transient, first order and second order transient. Okay, and we have steady state analysis of sinusoidal signal, mutual inductance, dot convention, right, locus diagram. So practice with what number of questions. Okay then sir, yes, kya Shruti, this is important for what? This is the basic for all electronics subject, right? So that is a session by Rakesh sir and Ankit sir. That is nothing is impossible. Non-stop math marathon, full syllabus coverage in 2 days. Day 1 29th January 11 AM and then again 31st January 11 AM. तो ये 2 डेट आप नोट कर लीजिए, ये आपके सामने डेट है, right? 29th and 30th January 11 AM. That is the maths by Rakesh sir and Ankit sir. And now just we will start with what first basic question, just for your warm up. थोड़ा सा वार्म अप कर लीजिए, बहुत सारे इंपॉर्टेंट क्वेश्चन आपका वेट कर रहे हैं. एंड आस्क योर फ्रेंड्स टू ज्वाइन द सेशन सो दैट, यार ये बहुत ही अच्छे क्वेश्चंस के साथ वी आर गोइंग टू डिस्कस व्हाट नंबर ऑफ कॉन्सेप्ट हियर. तो फर्स्ट ऑफ ऑल वेरी बेसिक क्वेश्चन. Here 100 volt is connected, here 110 volt is connected, 3 ohm, 20 ohm and 4 ohm. What should be the current through what 4 ohm resistor? This is the 4 ohm resistor and you have to find the current. Okay, please give me the answer. सब के सब यहाँ पर जरा अब बहुत ही तेजी से आ जाइए और अपने आंसर मार्क करना स्टार्ट कर दीजिए, राइट? यस प्लीज. ओके, देखिए now it is a very basic question, बहुत ही easy. आपको लगेगा सर this type of questions, yes we make it 1 marks question, right? Simply to disturb your what time management. कितना टाइम आप लगाते हो वो डिपेंड करेगा. If it is a question then you can apply what mesh analysis or what nodal analysis or what source transformation, right? If suppose I am going to apply what mesh analysis, yeah, or what simply source transformation. In case of source transformation, simply this will become Watch this diagram and everyone try to give me the answer for this question. Which answer is correct? That is the option A 4.278, option B 3.486, option C 2.813 and option D is what 1.315. Harish is giving the answer C. Okay, चलिए देखते हैं जरा आंसर सी है या नहीं है. अदर स्टूडेंट्स, व्हाट विल बी द आंसर फॉर दिस पर्टिकुलर क्वेश्चन? ओके, अब देखिए जरा, बहुत ही मतलब आपको लगाना है, जैसे आप बहुत सारे मेथड से यू कैन अप्लाई द मेश एनालिसिस, नोडल एनालिसिस, केसीएल और केवीएल, राइट? वी हैव टू अप्लाई द केसीएल एंड केवीएल. दैट इज सिंपली सोर्स ट्रांसफॉर्मेशन 100 डिवाइडेड बाय 3. दिस विल बिकम करंट 100 डिवाइडेड बाय 3 and in parallel it will become 3 ohm and that is what 20 ohm and that is 110. Why? Because we want current through the 4 ohm resistor. Now that is the case. This is the 20 ohm, this is the 3 ohm, this is the 20 ohm. Now 20 and 3 are in parallel, that is the 60 by 23. 60 by what? 23. When 60 by 23 multiplied with what? 100 by 3, this will again converted into what? Voltage source. So what is the voltage source here? And resistor 110, this is the 4 ohm. What is the current through the 4 ohm resistor? Now you can find the value. Okay, what will be the current? You can simply simplify this diagram. So this is 100 by 3 into what? That resistor 60 by 23, right? This is nothing but 2000 by 23. 2000 divided by 23 and this resistor is what? 60 by 23. Very simple question. अब आपका आंसर आ गया B for Bombay. Yes, that is the right answer. Okay, that is one way. So what is the current? I is equal to 110 minus 2000 divided by 23 upon total resistor 4 plus 60 by 23, and that will give you the answer. That is the B option. This is one method. This is what? One method. Yes, now you can apply what? Nodal analysis, or what you can apply what? Mesh analysis. तो वो है, just I'm going to give you the hint only. Okay, 1 minute. So for this question, first method is simply source transformation. That was the method. That is the source transformation. You will get the B option. Second method, you can apply what? Nodal analysis at this point. Let this voltage is Vx. You can write Vx minus 100 divided by what? 3 plus Vx by 20, that is the Vx by 20 plus what? Vx minus 110 divided by what? 4 is equal to 0. This is the sum of the incoming outgoing current. Let this is the I1, let this is the I2, let this is the I3. So I1 plus I2 plus I3 is equal to 0. That is called the nodal analysis. From this you have to find the value of Vx. Once you will get the value of Vx, what will be the current through the 4 ohm resistor? Only magnitude is required. Only the magnitude is required. Yes, we will discuss each and everything. What will be the current? Once you will get the value of the Vx, the current is, if that is the current in this direction I, it will become 110 minus Vx divided by what? 4 ohm. 110 minus Vx divided by 4 ohm. That is called nodal analysis. It's up to you. You can use what? Nodal analysis, or you can use what? Mesh analysis also. तो देखिए जरा, mesh analysis में third option ये है. If you want to write the mesh analysis, just watch this. Again you will get the B option. Again you will get the B option. Right. In mesh analysis, you can assume this current, let I1. You can assume this current, let I2. Use inspection method directly. 100 is equal to 23 I1 in the same direction, so plus 20 times of I2. That is the equation number 1. Here 110 is equal to 4 plus 24 I2. 24 times of I2 plus, this is in the same direction, plus 20 I1. right? That is equation number 2. We want I2. We have the two equations. Replace the I1 in terms of I2 and directly you can find the value of what? I1 or I2, sorry, I2 or what? Directly, I am giving you the hint. Directly apply the Cramer's rule. What is the, what is the 23? What is this 20? What is the LCM of 20? What is this 24? That will become what? Del. Everyone, you have the idea about the Cramer's rule? Please tell me. You have the idea about the Cramer's rule? Right. Okay. Now, del means what? Coefficient of 23, coefficient of I2, 23, 20, 20, 24. That is the del. Find the del. And what is the del 2? Because we want what? I2. We want I2. Then del 2 will become 23, 20. This row, this column, second column is replaced by what? 100 and 110. 100 and 110. That is called Cramer's rule. Second column of del is replaced by what? 100 and what? 110. Then you want I2. I2 will become what? Del 2 by del 1. Del 2 by del 1. Easy? Yes or no? 23 into 24 minus 400. That is the del. And what is the del 2? 23 into this. 110 minus what? 2000. Very easy. So it's up to you which method is easy. That is the Cramer's rule is clear to you everyone. This Cramer's rule. So देखिए, this is just a method, source transformation or what we can say mesh analysis or what simply source transformation. That is the method. Now what is the next one? What is the answer for the next question? An electric heater consume 1.8 megajoule. 1.8 megajoule. किसी को भी if you have any doubts then you can ask. Anyone if you have any doubt then you can ask on what source transformation or what on this method. If you have any doubt then you can ask. Okay. That is the method. This is a very easy method. Finally calculation and you will get the answer for this question. Then second method. Sir, here we used to convert what? PDF. इसकी भी मिलेगी और that I will upload the PDF of two previous classes also, Sulay. Right? Yes. PDF will be available, but first of all, watch this session and finally I will provide you the password and then you can get the PDF for this class with all solution and just within solution with the questions. I am trying to give you the concept. For example, what? Transient, for example, two-port network, about Barrett's bisection theorem, lattice equivalent, concept through questions. Okay, approximately 30 questions we are going to discuss from each topic. Okay, this is a complete revision of network. Okay, and then यार लेकिन एक बार जरा इसे शेयर कर लीजिए अपने ग्रुप में, दोस्तों को बुला लीजिए, जरा बताइए व्हाट इज द आंसर फॉर दिस क्वेश्चन. An electric heater consume 1.8 megajoule when connected to a 250 volt supply for 30 minutes. Find the power rating of the heater and the current taken from the supply. Question from the very basic concept. Okay. यस, आप बताइए ज़रा क्या होगा. Okay. Now, second one, an electric heater consumes 1.8 megajoule when connected to a 250 volt supply for 30 minutes. Find the power rating of the heater and the current taken from this value. देखिए जरा, अगर 1.8 मेगाजूल है तो what is this energy? 1.8 into 10 raised to power what? 6 joule. That is the energy. 250 volt supply. So what is the supply here? 250 volt. 250 volt is the voltage. That is the supply voltage. Right? So that is the heater. Connected to 250 volt supply. And this is the I. So it may ask what is the power rating of this heater. What is the heater? What is the power rating of this heater? And what is the current given by this? So current given by this, the answer given by the student is what? D. Yes, that is what current is what? 4 ampere. Yes, we can calculate. So what is the energy? Power is equal to energy by time. Energy by time. So what is the energy here? 1.8 megajoule. So 1.8 into 10 raised to power 6 upon time. What is the time? 30 minutes. Convert it into seconds. 30 minutes. Right? 1800. Now from this you will get the power, that is the 1000 watt. That is the normally that is the rating of what? Rating of heater. We are using in what? In cold weather, that is the 1000 watt. Now what is the current given? Power is equal to what? V into I. So what is the I is equal to? P by V. 1000 divided by 250, that is 4 ampere current is given by this voltage source. This is a very simple question. So 4 ampere is the answer, and if it is asked the power rating of the transformer, that is what? 1000 watt. 1000 watt. Okay, next question. It is just for your warm up. अब थोड़ा और आएगा क्वेश्चन का, हम लेवल बढ़ाते हैं. The figure in the figure, the maximum power delivered to RL is. What is the maximum power delivered to RL? कितना power deliver होगा? Load resistance. Yes, everyone. अब यहाँ पर देखिए, we have to use what? You learn about what? Maximum power transfer theorem, right? So here it is the R, here it is a 4 ohm, here it is a 2 ohm resistor, and here it is given as what? 2 ohm resistor. So in this question they may ask what should be the value of the R, what should be the value of the R so that maximum power is delivered to RL, and what is the value of the maximum power delivered to RL. Yes, please tell me. So figure is shown, the maximum power delivered to RL is, क्या होगा भाई आंसर? Normally according to maximum power transfer theorem we are having, this is the maximum power transfer theorem. Here battery is connected, here one resistor is connected, right? Here one voltage source is connected here, that is called Thevenins. We are calculating the Thevenins. This is called RTH, and here that is called load, RL. Now according to maximum power transfer theorem, RL should be equal to what? RTH. But what is the precaution here? Number of students given the R is 3 and answer is what? C. So what is the C? 50 watt. Okay. Now what should be the value of R? Some student name Mani is given what? Answer is 3. Sai Kiran Reddy is given answer 3. But my dear students, according to maximum power transfer theorem, when RL is variable, it should be equal to what? RTH. First of all, you have to find Thevenin's equivalent of any diagram. Everyone remember this. If that is the question, always remember in maximum power transfer theorem, which one is variable? RL is variable. If RL is variable, this RL should be equal to what? RTH. And what will be the current then? VTH by what? 2 RTH. And then what will be the power across the output? It will become I square into RL power is given by I square RL, it will become VTH square by what? 4 times of RTH. Why? Because RL is equal to RTH. But what is the condition here? Condition is RL is variable. But when the RTH is variable, what will happen? When the RTH is variable, always remember the power. If this is the VTH, this is the RTH, this is the RTH, this is variable, then there should be a maximum current through RL. So what is the current here? VTH by RTH plus RL. What should be the value of RTH? All are passive elements, passive, passive, passive. This should be equal to what? 0. Then we are getting the maximum current, and the power will be become I maximum square into what? RL. Because this time RTH is variable. So RTH should be equal to what? 0, and therefore R should be equal to 0. Okay, that is clear to you everyone? जिसने भी साई किरण रेड्डी मणि, this is a very general question, तो थोड़ा सा precaution रखिएगा, no problem. So in theorem RL is variable, but here RTH is variable and RL is fixed. And in this case, the power given by the battery, power given by this battery, in this case, first case when RL is variable, the power given by the battery is just double. What is the power given by the battery? 2 times of this. It will become VTH square by what? 2 RTH. And half of this power is wasted across what? RTH, and half power will be given to what? RL, because both are equal. And that's why it is what? 50% efficiency. 50% efficiency in second case. This is the case, 50% efficiency. Power conversion efficiency is 50% when RL is variable. And when RTH is variable, 100% efficiency. This much amount of power is given by the battery, and complete power is consumed by what? RL. Because it is 0, 100% efficiency. 100% efficiency. That will be the question on what? Maximum power transfer theorem. Okay, any doubt then you can ask. Yes. The next one, next very important question. So this is the complete idea about what? Thevenin's. Maximum power transfer theorem. Now what will be the answer for this question? Determine the Thevenin's resistance and the Thevenin's voltage for the given source, given circuit. Determine, right. Now determine the given resistance determine the Thevenin's resistance and Thevenin's voltage for the given circuit. Okay, what will be the answer for this particular question? Okay, now here we have the dependent source. When we are having the dependent source, then it is possible to calculate the resistance of the circuit, right? It is possible to calculate the resistance of the circuit, because we have to apply what? A battery. If we have the dependent source, apply the battery of what? 1 volt or what? 1 ampere current source, then you can find the resistor. But there is no active source, no active independent source is given in the particular diagram. If no active source is given in the diagram, then first of all, what is the method to find the RTH? Everyone give me the answer. What is the RTH for this diagram? Thevenin's resistor. When I want to calculate the Thevenin's resistor, because there is no active source, no active dependent source, no active independent source. Otherwise, if there is an independent current source, then it will act as open circuit. If it is independent voltage source, then it will act as what? Short circuit. But there is no source. So directly this diagram is, you have no need to remove any source. Simply you can apply a 1 volt battery here. Some students are applying V volt battery, or that may be V volt is equal to 1 volt and there is a current. What is the method? RTH is equal to V by I. RTH is equal to what? V by I. That is on the Thevenin's theorem. Okay. Ranit, you are giving the C option. Now I will check whether it is right or wrong. So that what is the C option? -1 ohm and not possible to determine. Okay. Then if it is a 1 volt, what is the current I? Like always remember. How? This is the I. What is the current here? Ix. What is the current here? I minus Ix. Yes or no? I minus what? Ix. That is the current. This is a one way. Or just I am going to give you what very simple method. What is the method here? Here V is equal to what? 1 volt. So this will become what? 1 by I. First of all, this is the equation number 1. Ix into 2. That is the voltage at this point. So this will become 2Ix. 2Ix, because this is the, remember this is the 2 ohm. So what is the voltage at this point? 2Ix. Write down the KCL at this point. When I am writing the KCL at this point, okay, what is the KCL? 2Ix minus 10Ix, 2Ix minus 10Ix divided by what? 4 plus 2Ix divided by 2, that is nothing but Ix, outgoing current is Ix, plus 2Ix minus 1 divided by 1, or simply you can say what is the incoming current? I. So that is the I is equal to I. This is the outgoing current, and that is what incoming current, that is the equation number 2. Now we want 1 by I, then you have to replace what? Ix. So from this equation, you are getting minus 8 divided by 4, minus 8 divided by 4 minus 2Ix. Is it clear? Minus 2Ix plus Ix. Plus Ix is equal to I. So what is the Ix is equal to? Minus I. Ix is equal to what? Minus I. Okay. Now 1 minus of 2Ix upon 1, that is equal to I. 1 minus 2Ix upon what? 1. So you simply put the value here, right? This has become I. 1 minus plus 2I, right? And this is minus I is equal to 1. So what is the 1 by I? Minus 1. This is called minus 1 ohm is the resistance here. Yes. You can also get the negative value. Always remember, you can also get the negative value of what? Thevenin's resistance. So if this is the Thevenin's resistance, that is not the 1 ohm, that is what? Minus 1 ohm. So some students, sir, how is it possible? So here it is possible. We can get what? Negative value also. And without source, it is not possible to determine what? VTH, right? Because there is no independent sources, only 10Ix is given, right? And that is what open circuit voltage. If you want to calculate the open circuit voltage, it is not possible to calculate. Otherwise, you can use, let the VOC is here. The voltage across this will become VOC. Then you can write the KVL and then you can check, because we have no idea about the Ix. Okay. Because there is no independent sources. So C is the option. Second thing, always remember, if we are getting the negative, if we are getting the negative resistance, for example, for any diagram, for any network, two-port network, any two-port network, let this is the RL. This is very important concept. This is the basic. Any network, RL is connected. We want, what is the maximum power? If I want the maximum power, I have to calculate what? VTH and RTH. VTH is called open circuit voltage and RTH is the Thevenin's resistance, and again we have to connect what? RL, and this RL is variable. So according to maximum power transfer theorem, what should be the value of RL? RL should be equal to RTH. Normally we are saying that RL should be equal to what? RTH. And what will be the maximum power? Maximum power is given by VTH square by what? 4 RTH, right? But if RTH is what? Negative value. If I am getting the RTH is equal to negative value, for example, I am getting the RTH is equal to minus 4 ohm. what will be the maximum power in that case, and what should be the value of RL? Please give me the answer in comments box. If I am getting the RTH negative, just like a previous question, we are getting the RTH is equal to negative value minus 4 ohm, and we have the some value of the VTH. Always remember the current should be maximum. What is the current? Maximum current is equal to VTH divided by what? RTH plus RL. And what is the power here? Power is given by I square into what? RL. So it will become VTH square into RL divided by RTH plus RL. When this current will be maximum, when the magnitude of both are equal, it is negative, it is positive. So put the RL is equal to what? Mod of RTH. That will become 4 ohm because it is a passive element. Because it is a passive element. So when it is a passive element, then what is the current? Any value of the VTH minus 4 plus 4. That is the VTH divided by 0. It will become what? Infinite. When the current is infinite, what is the power? Power will be infinity. Yes, Manish, your answer is correct. Manish Sutradhar. यहाँ पर जो power आएगा, that is what? Infinite. यह value. That is equal to what? Infinity. Okay. This is clear to you, everyone. Very simple concept. In any numerical, use the concept. If you are getting the negative value, don't worry, right? Simply the RTH negative, then RL should be what? Positive value, because it is a passive element. ये एक load है RL, passive element. So RL should be equal to mod of RTH. In that case, current will be infinite. Power given to the RL will be infinite. We are having the negative resistance device like what? Tunnel diode. Right, we have negative resistance device, tunnel diode, gun diode. Okay, so that is active. Positive resistance will consume power, negative resistance will deliver the power. Okay, that is negative resistance will deliver the power. How is it possible that we are getting the more power? Because of this negative resistance. Okay, right. Now next one. Yes. In the figure below, the equivalent resistance between A and B in ohms is. In the figure below, this is the 8 ohm resistor, this is the 8 IX, this is the terminal A, this is the terminal B, that is the IX. What is the resistance between these two terminals, between A and B? Between A and B, what will be the R equivalent? Yes, Anuradha, power absorbed, power delivered, definitely. Source resistance, the magnitude of, because that Sunny, you are giving the source resistance is equal to load resistance. Load resistance, because load resistance is variable, it should be the mod of what? Source resistance. Manish, it is right. Try to understand. It is we are talking about what? DC power. We are talking about the DC power. In case of AC, if sinusoidal signal is given, then if nothing is mentioned, it will be RMS value. Already it is RMS value. If nothing is mentioned, if it is mentioned that it is a peak value, then you have to find what? RMS value. I will discuss one question, right? Just after that, I will give idea about that. If it is a DC, it is always for RMS value of the DC is the same value. So no, this is the DC value. If this is the DC value, then directly you can find the power by that method, VTH square by 4 RTH. But if it is AC, nothing is given, then in GATE exam it will be the RMS and the formula will remain same. But if the peak value is given, then you have to find what? RMS value. Okay. What is the answer for this question? 16 ohm. That is a numerical answer type question, NAT. Numerical answer type question, that is the NAT. No negative marking. So everyone give me the answer. Okay, Kisan is giving the 0 answer. Ranit Ghosal is giving 0. Right. Now always remember 8 ohm, 8 IX. If the equivalent resistor across A and B is required, then connect a battery of voltage V volt here. And what is the current given by this I? What is the RAB? RAB is nothing but V by I. Now, when I am writing the KVL, what is the relation between I and Ix? Here it is the I. Ix is equal to what? Minus I. Ix is equal to minus I. So write down the equation. V is equal to 8I KVL. I am writing the KVL. V is equal to 8I plus 8Ix. 8I plus 8Ix. What is the Ix is equal to minus I? It will become V is equal to 8I minus 8I. Right? So V is equal to what? 8 minus 8. I am taking the common I. What is the V by I? Is equal to 0 ohm. This condition is possible for what? 0 ohm. This condition is possible for what? 0 ohm only. Is it clear, Monisha? Right? ये है condition. Write down the equation. V by I is the nothing but the voltage across terminal A and B. Find the resistance across A and B. That is the value. Or for any circuit, whether it is a network or analog or any in number of circuit, we have to find what input resistance. For example, in operational amplifier, we have to find the input resistance or what resistance across these two terminals. If the resistance is required, always remember voltage upon current given by that voltage. Voltage upon current given by that voltage, and you can find the value. अरे भाई जरा इसको एक बार अपने ग्रुप में आप लोग शेयर कर लीजिए. Please share the link. Number of students want this session because quick revision of network is required. Live classes is important, right? No doubt I will upload the PDF after the class, but it is a concept through what questions? Concept through questions. If you have any doubts, then you can ask. Sir, that topic is not clear, or if you want some details, again you can, right? So it is a session, simple concept through numericals. Right, approximately 30 numericals. With 30 numericals, you are going to get the idea about what all the topics. Okay. Then for the figure 1 and figure 2, Z, A, B are equal. Sometimes on elements, this type of equations is required. This is the terminal, and that is the Z equivalent, and this is the Z equivalent for this diagram. For both the diagrams, Z equivalent are equal. What is the value of C1 and what will be the value of the C2 and L2? Now, just question on what elements. When the question on elements, always remember, large value of capacitor is very difficult to get the large value of the capacitor. Maximum power, yes, Manish, we will discuss one question on what? AC circuit, right? Maximum power transfer theorem with AC circuit, definitely, where only RL is variable. I am going to give you the hint for that. Okay, for the figure 1 and 2, Z, A, B are equal. Find the value of C1, C2 and what? L2. Find the value of the C1, C2 and what? L2. So always remember, we want this circuit, 1 farad and 1 Henry. What is the practical problem? The high value of the capacitor is not possible and low value of inductor is not possible, because it is very low value of the inductor is here. 1 Henry is a very low value of the inductor, and this is what 1 farad is very high value of the capacitor. How we can design? We have to reduce what? No need to find the frequency here. No need to get the idea about the frequency. Simply equivalent circuit, then this the value of the C1 and C2 will be less than what? This 1 farad will be less than 1 farad. Second, the value of these two inductor will be greater than what? 1 Henry. And always remember, when inductor are connected in parallel, the value of the inductor will reduce. When the capacitors are connected in parallel, value of the capacitor will what? Increase. But these two are connected in what? Series. So that is a standard diagram. That is a standard practice for this diagram to convert into this diagram, or from this diagram to this diagram. So what is the standard practice? If this is the C and this is the L, then product of LC. If I am having the combination of the two, so this is the C1 L1, C2 L2, or we can connect the C3 L3, C4 L4. But if two are connected, then L1C1 is equal to what? L2C2 is equal to what? L3C3 and so on. What is the L and C? 1 into 1. So that is what? Nothing but L1C1, L2C2. Or in this way, you can directly give the value of the C1. What is the value of the C1? Yes. So directly, Ayan, your answer is correct. The C1 is equal to what? 1 by 6 farad. 1 divided by L1, that is 1 by 6 farad. Right? So what about this value? This is less than what? 1. It should be less than 1. From the option you can give the value. So in 27th, on 27th, just after 26th, right? तो कल तो आप हॉलीडे मनाइए, ओके? अब देखते हैं, हैप्पी रिपब्लिक डे आप लोगों को. Then value will decrease. On 27th, I am going to give one session on what? MCQs. How we can handle the MCQ. What about the calculated risk, right? Or some general practice, so that we will be able to solve each and every MCQs. We have to take some calculated risk also, elimination method, each and everything on what? MCQ. And that session is very, very important for what? Coming exams like GATE 2022. Okay. तो अब देखिए यहाँ पर, तो if you have idea, this value of the capacitor should be less than what? This value, then definitely you can choose the option. C2 will be always less than C. L1 greater than L2, also greater than what? 1 Henry. So what is the, that is 1 by 6 farad. Now this is the parallel combination of these two. Parallel combination of these two should be equal to, what is the Z equivalent? Tell me. Here the Z equivalent is given by SL plus what? 1 by SC. It will become S plus 1 by S. S plus 1 by S. So what is the Z1 here? Z1 here 6S plus what? This is the SL1 plus what? 1 by SC1, right? And here we are writing that Z1 is equal to 6S plus, because C1 is 1 by 6, 6 by S. You are taking that 6 as a common, S plus 1 by S. S plus 1 by S. Let L2 is equal to what? X. So what is the C2 will become 1 by X. C2 will become 1 by X. What is the Z2 will become? XS plus what? X by S. X by S, because C2, okay, SL2 plus 1 by SC2. So it will become XL2 XS plus X by what? S. Okay, you can take X as a common, S plus 1 by S. That is the method. Now what is the parallel combination of this 6 and what? X? That should be equal to what? 1. The parallel combination of 6 and X, these two are the impedance, because this term is common, this term is common. So what is the Z equivalent here? Z1 parallel with Z2. So you can take the common term, S plus 1 by S. Simply calculate the parallel of 6 and S. It will become 6X upon what? 6 plus X. And that should be equal to what? S plus 1 by S. Because the equivalent circuit impedance are same. This term is cancel out. Everyone give me the value of the X here. When I am taking the value of the X here, this will become 6X is equal to what? 6 plus X. What is the X here? 6 by 5. So X is 6 by 5, means the value of this is 6 by 5. So what is this? 5 by 6 farad. 5 by 6 farad. तो आंसर क्या दिया भाई आपने? आंसर दिया है अयान मलिक 1 by 6 farad. And what is the answer for the other one? Everyone, that question is clear to you, everyone? This is a very, very general question from, right, that is on cap elements. The equivalent impedance for this diagram is SL plus 1 by S, or that is the value of the L is 1 Henry, value of the C is what? 1 farad to S plus 1 by S. Then from every combination you are going to get what? S plus 1 by S common. For example, here you are going to get the S plus 1 by S common. Here again you are going to get the S plus 1 by S common. And then what? Parallel combination is given by Cx upon C plus X. If you have the common, then you can remove that common value, okay, and then equate it, and then you can equate it. The answer for this is what? 5 by 6 farad, and this is what? 6 by 5 farad. Common sense, always remember this value should be less than this value, this value should be less than this value, this inductor should be greater than, this inductor should be greater than what? 1 Henry, and 6 by 5 is greater than what? 1 Henry. So I think this concept is clear. Next question. So that is the question on what elements? That is the question on elements. अब जैसा ये देखिए, ये है, that is the question, that is another question. Give me the answer. The RLC series circuit shown in the figure. RLC series circuit is shown in the figure. Yes, Dheer, sir, that trick what? LC is equal to L1 C1 and L2 C2, because we are connecting in a parallel. We are connecting in parallel. This condition will satisfy that we can take common what? S plus 1 by S, right? If we are taking L1 C1 is equal to L2 C2 is equal to what? L3 C3. In this question we can apply this type of question. Normally this type of question, very lengthy, but don't confuse. Always remember everyone, if that is the question again, right, let this is the C1 L1, C2 L2, C3 L3. That is the question, same question. CL. So remember this, L1 C1 is equal to what? L2 C2 is equal to what? L3 C3 is equal to what? LC. That is the general, and then the value will be given, and the value will be given. So you have one unknown values. So here the parallel combination of this, always remember it has x1 S plus 1 by S, x2 S plus 1 by S, x3 S plus 1 by S, right? And that will be the value. Here you have any value, for example it is a 2 or 3, and if you have, then you can take S plus 1 by S as a common. Always remember S plus 1 by S as a common. Then simply you can apply, and then x1, x2 and x3 parallel combination, that should be equal to that. Compare these two and you will get the answer. Okay, that is a trick skill. अगर यहाँ पे discuss करेंगे तो फिर we will discuss only one question. That is the question from the basic of the inductor. Okay, we are calculating the Z equivalent of both the diagrams and equating it. We are getting one condition, right? It is a necessary condition but not the sufficient. Not the sufficient. Now please tell me, RLC series circuit shown in the figure are, or everyone read question carefully. Read question carefully. Go through the proper units. So RLC series circuit shown in the figure, R is equal to 22 kilo ohm, L is equal to millihenry, 20 millihenry, C is equal to in microfarad. The initial energy stored in the inductor is 2 millijoule, and the initial energy stored in the capacitor is 1 millijoule. 2 millijoule and what? 1 millijoule. This is the initial energy stored in the inductor and what? Capacitor. The value of dLi by dt, that is the question on what? Initial condition. That is the question on initial condition. What is the rate of change of current for 0 positive? Kilo ampere per second. What is the unit here? Kilo ampere per second. Okay, what will be the value? And that is the direction of the current, and that is what? V. This is the direction of the current, right? Now I want to ask one thing. One thing, just direct from the concept, that value will be negative or positive? Tell me. Here MCQ, some concept is required. So that value will be negative or positive. Yes, please, direct. DIL by dt, it will be negative or positive. Okay, then. Here we are having the inductor, resistor, and what? One capacitor. Now, try to understand. Give me the answer. First, energy stored in the inductor is given by half of Li square. That energy is given as 2 millijoule. So this is the 2 millijoule. What is the value of the inductor? Inductor is given as 20 millihenry. Remember this. Into I square. So this is nothing but initial value of the current square. That is equal to 4 millijoule. This is 2 into 2, 4. This is milli cancel. So what is the I is equal to? Root over 4 by 20. 1 by root 5. 4 by 20 is nothing but 1 by root 5 ampere. Why ampere? Because this milli and milli is what? Cancel out, and that is will become, that is the initial current through the inductor. Initial current through the inductor is what? 4 milliampere. Ayan Malik, it will be what? Negative, because it is a source free circuit. The inductor will what? Discharge. चलिए चेक करते हैं जरा, चलिए चेक कर लेंगे. Conceptually, what is the voltage V and R? We will check. Okay, no problem. Now 20 millihenry. Now try to understand, just then I will give you the concept. 20 millihenry, 1 by root 5 ampere. Second thing, what is the voltage across, energy across the capacitor? Half of CV square, initial voltage, that is equal to, given as 1 millijoule into 10 raised to power minus 3. Now what is the value of the V? 2 into 10 raised to power minus 3 divided by what is the value of the C? 20 microfarad. 20 into 10 raised to power minus 6 raised to power 1 by 2. This 2 is multiplied, and that is. Now this is the 2 10, this is cancelled, 1000, or yes, please tell me what is the value of what? V volt. Now you will find the value of what? V. You will find the value of what? V from this point. This is called initial voltage across what? Initial voltage across the capacitor. Okay. तो देखिए, half of CV square, that is given as 1 millijoule, initial energy stored in the capacitor. You can find the initial voltage across this, right? अब आपके पास है, I think root 100. That is what? 10. I check this. What is the value? Please give me the value. Now, once you will get, that is what? 10 volt. Okay, no problem. 10 volt. Once you will get the value of this voltage, and then simply in this diagram write down the equation. This is the VL, right? This is the current IR. So exactly at t equal to 0 plus, what is the equation? What is the voltage across the inductor? L di by dt. This is the voltage across the inductor, L di by dt, plus what? Ri plus what? V is equal to what? 0. Now what is the initial value of the current? It is known, right? You can find the di by dt is equal to minus V plus IR divided by what? L. V plus IR divided by what? L. That is the answer. Okay, then you can find the value. Easy? चलिए बताइए जरा. यहाँ पर देखो, आपको पूरा प्रॉपर यूज करना है. दैट इज द एनर्जी गिवन बाय द इंडक्टर, हाफ ऑफ Li स्क्वायर. कैलकुलेशन आप चेक कर लीजिए, कॉन्सेप्ट मैं बता रहा हूँ. दैट इज द वैल्यू, एंड फाइंड द वैल्यू हाफ ऑफ CV स्क्वायर. फ्रॉम दिस you can calculate the value of the voltage. This is nothing but initial voltage across the capacitor exactly at 0 plus, and then from this write down the KVL, L di by dt plus Ri plus what? V. That is nothing but voltage across initial voltage. Capacitor does not allow sudden change of what? voltage. Capacitor does not allow sudden change of voltage. Inductor does not allow sudden change of the current, but it allows the sudden change of voltage. KVL should be satisfied. Write down the KVL. L di by dt plus R, Ri plus what C, no need to write directly, you can write the V. You have the initial value of the voltage and so on. Now, put the values and you will get the answer. Minus what is the initial voltage? V. You are getting the answer 10 volt. This is the 10. Right, and that is what is the initial current? 1 by root 5 into what is the value of the resistor? 22 kilo ohm into 10 raised to power 3 divided by value of the inductor 20 millihenry. आगे आंसर ये आ गई वैल्यू. यस, उसी के आसपास है. दैट इज द 492 समथिंग होगा कुछ. वन मिनट. वन मिनट हो गया. अब आते हैं नेक्स्ट क्वेश्चन पर. तो ये है इनिशियल कंडीशन. ऑलवेज रिमेंबर कैपेसिटर डज नॉट अलाउ सडन चेंज ऑफ वोल्टेज और इंडक्टर डज नॉट अलाउ सडन चेंज ऑफ करंट. सेकंड थिंग, समटाइम्स they want, right, they required what is the value of dv by dt here in this question. What is the value of the dv by dt? dv by dt 0 plus. Yes please, in comments box give me the answer. What is the value of dv by dt 0 plus? Right, that answer is what? Kilo ampere per second. Answer is not kilo ohm. अनुराधा, हाँ यस, आप ये किलो एम्पियर पर सेकेंड. किलो एम्पियर पर सेकेंड, बिकॉज इट इज डी आई बाई डी टी. तो ये दिया ना, दैट इज किलो एम्पियर पर सेकेंड. किलो एम्पियर पर सेकेंड. बताइए जरा क्या होगा आंसर भाई. -492.42. यस बिल्कुल सही, -492.43 किलो एम्पियर पर सेकेंड. ओके. अरे इतने लोग अगर यहाँ पे अटेंड करें, जरा एक बार लाइक बटन तो प्रेस कर दीजिए अगर आप लोगों को सेशन समझ में आ रहा है. एवरीथिंग इज फाइन. अपनी अटेंडेंस दे दीजिए. थोड़ा एक बार पूरे अपने कमेंट्स भी डाल दीजिए. ऑल आर प्रेजेंट. थोड़ा इसको थोड़ा दिखाइए जोश के साथ. हाउ इज द जोश? थोड़ा पूरी एनर्जी लगा दो यार, हम लोगों को भी एनर्जी आनी चाहिए. तो कैसा लग रहा है? व्हाट डू फील अबाउट द सेशन? एवरीथिंग इज फाइन. Now we are going to discuss what some important numericals on what transient. Okay, RLC with impulse source etc. One question please sir, general method बता दीजिएगा जिससे क्वेश्चन. हाँ मैं बताता हूँ, एक बहुत ही इंपॉर्टेंट क्वेश्चन मैं आपको बताता हूँ on what RLC circuit just after this. So first of all give me the answer. What is this? What is the value? Always remember when we want the dv by dt 0 plus, dv by dt 0 plus, this is the I. This is what I, right? If that is the high I, तो सब भाई जरा पूरा रिस्पॉन्स आग लगा दीजिए सेशन में. आ जाइए सब के सब. ओके, पूरी फुल एनर्जी के साथ, फुल मोटिवेशन के साथ. राइट, व्हाट इज द dv by dt? दैट dv by dt is nothing but the current through the capacitor is given by I, C dvc by dt. C dvc by dt. So what is the dv by dt 0 plus? This is nothing but I 0 plus divided by the C. What is the initial current here? The initial current through the capacitor is nothing but 1 by root 5. If it is 1 by root 5, to calculate the value, this is the milli cancel. Calculation is everything is fine. Okay, no problem. So 1 by root 5, you can put the value. So dv by dt 0 plus will become 1 by root 5 upon C. What is the value of the capacitor? 20 microfarad. So 20 into 10 raised to power minus 6. That is the answer. volt per second. Volt per second, that will be the answer. Okay, okay then. अब आते हैं जरा नेक्स्ट उस पर. यस यस यार, हाँ ये दे रही है, धीर ने दिया इन मेगा वोल्ट पर सेकेंड, तो मेगा वोल्ट पर सेकेंड और समथिंग जो भी है, दैट विल बी द आंसर. So these are the questions on what initial condition. Now one student asked, what is the, sir, impulse, what is the role of the impulse function? So try to get this question. Just I am giving you the very important question on the impulse, right? Watch this diagram. This is very important, right? Just watch this diagram. Let, these are the values. This is the 20 ohm resistor. Let, this is the 10 ohm battery. Here I am connecting a 60 volt battery. Okay, one capacitor is connected here. Let, this is the C. Tell me exactly at t equal to 0, the switch is closed. Everyone, exactly at t equal to 0, switch is closed. And try to understand, when t equal to 0, the switch is closed, right? Initially that capacitor is unenergized. Initially the capacitor is unenergized. So tell me, what is the initial voltage at this point? Everyone, what is the initial voltage and what is the final voltage? Tell me the answer. I am giving you very important concept on what impulse signal, everyone, right? Very important concept on impulse signal. So this is the t equal to 0, that is the switch is closed, it is visible to you. Yes, 10 ohm is the resistor C, and that is the 20 ohm resistor. And initially capacitor is unenergized. Initially the capacitor is what? Unenergized. So everyone, in this diagram, if the initially the capacitor is unenergized, it will act as what? Short circuit. Why? Because initial voltage across the capacitor, V0 negative is equal to what? V0 positive is equal to what? 0. Because capacitor does not allow sudden change of what? Voltage. Capacitor does not allow sudden change of voltage. So initial voltage is 0. So what is the? It will act as short circuit. So what is the current here, everyone? This will act as short circuit. And this battery is of 60 volt. This battery is of 60 volt. And this is of 10 ohm. So what is the initial current? 60 divided by 10, that is the 6 ampere. Initial current is what? 6 ampere, right? Now, last thing I want to ask, what is the final current, final voltage across the capacitor? Finally, because it is a DC source, this is a DC. If it is, this is the plus minus given, nothing is mentioned, I am giving you the answer. This is the DC source. If it is the DC source, so finally for DC source, capacitor will act as open circuit. So what is the final voltage? The final voltage we can find by the voltage division rule, because this will act as open circuit. This is the 20 ohm, this is the 10 ohm, this is the 60 volt, this is the DC voltage. For DC voltage, capacitor will act as open circuit under steady state. So what is the final voltage? Final voltage is become 10 divided by 10 plus 20 into what? 60, 40 volt. 40 volt, okay? This is the answer, 40 volt, everyone. Now watch another question and give me the answer for this question. This is a very important concept on transient. You will get the question on this impulse, right? Another question. Watch this. This is the 60 volt again. This is the DC source. This is the key. Again, there is a capacitor is connected here. Now, this is the value. Try to understand. This is the 20 ohm. This is the C2. I am having one capacitor here C1, and this is what R1, that is the 10 ohm. Exactly at t equal to 0, the switch is closed, and this is the 60 volt battery. Tell me, what is the initial voltage across the capacitor? What will be the initial voltage across the capacitor? This is a very standard question on what initial condition, right? First, right, here we are having the capacitor C1, here we are having the capacitor C2. C1 and C2 are here 10 and 20 ohm. Now tell me, this is the another question. Capacitor is initially unenergized circuit. This is the unenergized circuit. Unenergized means the energy across the C1 and C2 is 0. Unenergized circuit. At t equal to 0, switch is closed. Switch is closed. Then what is the initial value of this V0? That is nothing but Vc2 at t equal to 0 plus. What will be the answer? What will be the answer for this question? Okay, tell me. So here, if you are giving the 0 answer, because capacitor does not allow sudden change of voltage, and you are going to give the 0 answer, right? Vc2 is equal to 0. Anuradha Tiwari is giving the answer that Vc2 is equal to 0. So my dear friends, in this question, if the C2, try to understand, this is very important. This is very important, है ना? तो डाउट ही तो क्लियर कर रहे हैं. व्हाट इज योर डाउट? प्लीज पोस्ट योर डाउट. ईडी स्पेशलिस्ट, राइट? एक बात बताओ, तुम किस ईडी का मतलब क्या है? व्हाट इज योर स्पेशलिस्ट ऑफ व्हाट? इंजीनियरिंग, ड्राइंग और एनीथिंग एल्स? Okay, I am here to provide the solution for your doubts. You can ask your doubts. If it is relevant, then definitely I will give the answer, right? If the C2 will not allow the sudden change, then C1 will also not allow the sudden change. When both will not allow the sudden change, then what will happen? This is the 60 volt battery. This capacitor will act as short circuit. This capacitor will act as short circuit. Both will act as short circuit because both the capacitor will not allow the sudden change. This is the C1 and that is the C2. So what will be the current through the circuit? Tell me. Exactly at 0 plus. If both voltage across both the capacitor is 0, so KVL, what about the KVL? So we can write the KVL. 60 is equal to Vc1 plus Vc2 and that is equal to what? 0. How is it possible? How is it possible? KVL is violated. KVL is violated, right? If the KVL is violated, then capacitor will allow what? Sudden change of voltage. In this case, the capacitor will allow the sudden change of voltage. Why the capacitor will allow the sudden change of voltage? Again watch this diagram. Again watch this diagram, right? Yes, capacitor will allow sudden change of voltage to satisfy the KVL because there is a violation of the KVL. And to satisfy the current, always remember voltage across the capacitor is given by Q by C. What is the Q? 1 by C integral of I dt, 0 to t. If the current is finite, it will never allow sudden change of voltage. If the current is infinite or impulsive, what is the del t of dt? Everyone, from my 0 negative to 0 positive, what is the integration of impulse function from the signal and system? It is the 1. When we are integrating the impulse function, unit impulse function, 0 negative to 0 positive, it will give you the finite value. Yes or no? And what is the interval? Only 0 interval. So capacitor will allow the sudden change of voltage in 0 interval if the current is infinite. If the current is infinite, watch this diagram. Exactly at t equal to 0 plus, both the capacitor will act as short circuit. What is the current here? The current here is V by 0, that is what? Infinity. If the current is infinite, if the current is infinite, the capacitor will allow sudden change, or sudden change, we are having the infinite current. This infinite current will develop a finite voltage in this diagram. What is the finite voltage here? A finite charge here. What is the finite charge here? This is given by 0 negative to 0 positive I dt, and that is given by C equivalent into V. What is the C equivalent? C1 C2 divided by what? C1 plus C2 into V. Why? Because both the capacitors are connected in series. So what is the C equivalent? C1 C2 by C1 plus C2 into V. So that is the initial charge. That is the initial charge. And in a series, the charge will remain same. Same charge will flow through the C1 and same charge will flow through the C2. Tell me, what is the initial voltage across the C2? And that's why the initial voltage across the C2 is given by C2 divided by voltage division rule. C2, that is the, I am just giving you the formula, Q0 divided by what? C2. Q0 divided by what? C2. So C2 cancel. What is the answer? C1 divided by C1 plus C2 into what? V. That is the answer. What is the V? 60 volt. What is the V? 60 volt. So answer is C1 divided by C1 plus C2 into what? V. 60 volt. And similarly, what is the voltage across the capacitor? C1. C2 divided by C1 plus C2 into what? 60 volt. That will be the answer. Everyone, this is clear to you? And this is called what? Nature of impulsive current. How the impulsive current is possible in this diagram and how the capacitor will allow the sudden change of voltage. Clear? If you want another question, then I am giving. If you are interested, यार यहाँ पे number कम हो जाते हैं. When we are enter into what? Conceptual questions, students simply leave the class. But in GATE exam, we are going to get this type of questions. Always remember this type of questions, conceptual questions, 1 marks or 2 marks. Okay. Now, this is the initial voltage across the capacitor because of this two capacitors. So, C1 upon C1 plus C2 into 60. In this diagram, what was the initial voltage across the capacitor? In this diagram, the initial voltage across the capacitor was 0. In this diagram, initial voltage is 0. Now, final voltage is what? 40 volt. Yes or no? The final voltage is 40 volt. Initial voltage is what? 0. Right? And what is the final voltage? General formula R2 by R1 plus R2. Okay? R2 by R1 plus R2. If this is the resistor, so tell me, in this diagram, what is the final voltage? Finally, if it is R1 and it is R2, so finally at t equal to infinite, both the capacitor will act as open circuit, and the final voltage general formula is given by, this is the R1, this is the R2. The final voltage across this at t equal to infinite, this is the 60 volt, is given by V2 infinite is equal to R2 by R1 plus R2 into what? 60. This will be the answer for final voltage. Or sometimes, what is the question? 2 marks question. What is the condition? What is the condition so that initial voltage and final voltage are equal? What is the condition so that initial voltage and final voltage are equal? So what is the initial voltage? So V initial is equal to what? V final. What is the initial voltage? C1 divided by C1 plus C2 into what? 60. What is the final voltage? R2 divided by R1 plus R2 into what? 60. So 60 cancel, and this will become C1 R1 plus what? C1 R2 is equal to C1 R2 plus C2 R2. C1 R2 cancel, and what is the well known condition? R1 C1 is equal to what? R2 C2. R1 C1 is equal to what? R2 C2. That is the condition. That is the condition. Yes, whenever the KCL and KVL is violated, we have to go for this type of analysis. Otherwise, you will get the wrong answer. Always remember the basic law is what? KCL, Kirchhoff's current law, and Kirchhoff's voltage law. Kirchhoff's current law is based on law of conservation of charge. Kirchhoff's voltage law is based on law of conservation of energy. Energy can neither be created nor be destroyed. So ये जो है, that is the basic law. If it is violated, then capacitor will allow the sudden change of voltage. Inductor will allow the sudden change of current. Okay, ready? This is clear. And finally, don't worry. Finally, initial voltage means current division rule. Apply the current division rule. What is the current division rule for the capacitor opposite to the resistor? What is the current division rule? If you want the initial voltage across the C2 multiplied what? C1 divided by C1 plus C2 into what? V. If you want the voltage across the C1, initial voltage, I am talking about the initial voltage, C2 upon C1 plus C2 into V. This is called voltage division rule. Once you will get the concept, you can directly go for what? Solution. Directly go for solution. And if the condition is required, if this is the R1, that is the R2, this is the C1, that is the C2, initial voltage and final voltage should be equal. So R1 C1 is equal to what? R2 C2. That is the question from what? Analog. In analog, they will ask, right, this type of questions. Okay. Now, I think everything is clear. चलिए एक और मैं आपको क्वेश्चन दे दूं, जरा मुझे बताइएगा इस what will be the answer for this question. Everyone, I want answer. Are you ready? Ten ampere current very simple question. 3 Henry, exactly at t equal to 0 the switch is closed. Exactly at t equal to 0 the switch is closed, है ना? Yes. Rahman, what is the question? Capacitor allow the sudden. 1 minute here, Rahman, please put your comments again if you have any doubt. And everyone, a happy Republic Day, right? So enjoy. Are you enjoying the session? Just your Republic Day में भी आग लगाना है. आप जरा बताइए. Please explain this. Yes, GB, Kevin, Arjun, if it is this is clear. So initially the circuit is unenergized circuit. Unenergized circuit. Right, at t equal to 0, switch is closed. Find IL2 0 plus. This is the L2, and this is the IL2. This is the IL1, and that is the 10 ampere current source. But initially there is no current. Initially there is no current. Yes, tell me what will be the answer. तो मैं आपको टेलीग्राम चैनल का लिंक भेजता हूँ. एवरीवन प्लीज ज्वाइन दैट टेलीग्राम चैनल सो दैट यू विल गेट द PDF ऑफ दिस क्लास एंड सब्सक्राइब दिस चैनल सो दैट यू विल गेट द नोटिफिकेशन फॉर ऑल माई क्लासेस और अदर इंपॉर्टेंट सेशंस. So this is my Telegram channel, Electronics by Sanjay Rathi. Join this Telegram channel, and on Tuesday we have one important session on what? MCQs. How to handle the MCQ, multiple choice questions, calculated risk, elimination method, and within 20 to 30 minutes I will share my complete experience with you. और यार मजाक नहीं है, already I have qualified engineering services exam multiple times. So I have idea how to handle the MCQs in competitive exams. Okay, so that is the session for you. If you want the detail about that, then join my session, right, and subscribe that channel. You will get the notification about that. Join my Telegram channel. I will upload the link for that. Okay, so Arnab, What is the answer? Yes, Ayan Malik is giving the 4 ampere. Hello sir, namaskar. Raj, namaskar भाई, प्रणाम. Okay, तो चलिए बताइए जरा, what will be the answer? Now 10 ampere, 2 Henry and 3 Henry. Okay. Now again the similar concept. Again the similar concept, my dear everyone. Abdul Rahman and Mani and Arnab, try to understand this concept. Again with this question, try to understand the concept, everyone. This is the question on what? Inductor. This is the question on inductor. Okay. Initially the question was on capacitor. Now it is a question on inductor. What is the initial voltage? Initially it is unenergized. So what is the IL0 negative is equal to 0. What is the IL0 negative? IL2 0 negative, it is 0. Inductor, according to the normal concept, inductor does not allow sudden change. It should be equal to IL0 positive. Yes or no? You are giving the answer. Why? In general case, inductor does not allow sudden change of what? In general case, inductor does not allow sudden change of current. Yes, Dheer. Now you are getting this. Yes, name. That is the right answer. Money. Right? So that if according to the general concept we are going, inductor does not allow sudden change of current. If inductor does not allow sudden change of current, then what will happen? This will act as open circuit. This will act as open circuit. So what is the IL1 and IL2? 0. So what is the KCL? KCL, incoming current 10 ampere. Incoming current 10 ampere is equal to, right, 0. So this will become 10 is equal to 0. How is it possible? How is it possible? 10 will become 0. How is it possible? What about the KCL? Violated. KCL violated. Kirchhoff's current law is violated. If the KCL is violated, inductor will allow the sudden change of what? Current. Inductor will allow the sudden change of current. Up current, so for current, what is the current formula for the current? I is equal to 1 by L integral of what? V dt. 0 to 0, right? 0 to t, but we want 0 to 0. This voltage should be what? This voltage should be infinite or impulsive voltage. Its voltage should be impulsive. So my dear friend, what is the Z equivalent? Everyone tell me, what is the Z equivalent of open circuit? Everyone tell me, what is the Z equivalent of open circuit? Everyone, what is the Z equivalent of open circuit? This is the diagram exactly at 0 plus. Current is finite 10 ampere. And this will act as open circuit, this will act as open circuit. What is the Z equivalent of open circuit? Infinite. Infinite. So what will be the voltage? Voltage will become I into Z. Infinite. If we are having the infinite voltage, it will develop what? Finite flux. What is the flux? Psi is equal to integral of V dt. So what will be the finite flux? Always remember the finite flux, right? We want to calculate. So then first of all calculate the flux, and then what is the current? Current through the inductor is given by IL1 is equal to psi. Psi is equal to Li1. This is what? L1. What is the psi 2? Psi 2, right? Try to understand. This is the psi, oh sorry, IL2. IL2 is equal to psi by what? L2. What is the flux? L equivalent, integral of V dt. So we have to calculate L equivalent into I. What is the L equivalent? In parallel, these two inductors are connected in parallel. So in parallel, what is the inductor, everyone? L1, L2 divided by L1 plus L2 into what? I. L1, L2 divided by L1 plus L2 into what? I. Is it clear? This is the flux. So what is the IL2? When I am dividing this flux by this, it will become L1 divided by L1 plus L2 into what? I. What is the answer? What will be the answer? 2 divided by 2 plus 3 into 10, that is the 4 ampere. 4 ampere. Simply current division rule through the inductor. Current division rule through the inductor you have to apply. But basic concept is this one. Basic concept is what? Like this. Okay? तो basic जो concept होता है वो आपका value ये है. Flux and so on. what is the V? D psi by dt. So what is the psi? V dt. Or you have to integrate from what? 0 negative to 0 positive. If this is impulsive, then it is possible. What will be the value? L equivalent into I. So what is the L equivalent? That is the value. I think now everything is clear to you. Always go through the basic. If suppose we are mugging up, we are trying to mug up all these things without concept. So how, what is the flux? We are simply going to use what? Current division rule, but it is not possible. Now it is clear, everyone. Arnab, namaskar. Now it is clear. Okay. So what is the answer for this question? If directly in any numerical, if you want, directly you can write current division rule. Directly you can write the current division rule. That is what? 2 divided by 2 plus 3 into what? 10. Answer is 4 ampere. And what is the current through that value? IL1 0 positive, that is nothing but 10 minus IL2, that is nothing but 6 ampere. 2 ampere and 6 ampere, this is the right answer. Or in case of capacitor, if they are connected in series, always use what? Voltage division rule. Voltage division rule. So here, this is a very, very conceptual questions, and this is from what? Standard textbook. Standard textbook. Dhire one, that is impulsive, is what? What is the strength of the impulsive? Everyone tell me. What is the impulsive signal? Impulsive signal exists for, what is the impulsive signal? From the signal and system, that is the impulsive. Everyone watch this diagram. What is the impulsive signal? This is the width. That is the case. What is the area of this? If it is tau p, it is 1 by tau p. What is the area of this? 1. Right. Second, we are increasing. This is the decreasing. What is the area of this? This is the tau p dash. This is the 1 by tau p dash. Right. Again. Or when we are again decreasing the area, again decreasing the width. Let this is tau p double dash. This will become 1 by tau p double dash. So every time when we are increasing, but area will remain what? 1. So if tau p double dash tends to what? 0. So what is the 1 by tau p dash? Tends to what? Infinity. So it has what? Impulsive strength. Right? Impulse signal is what? Has what? Infinite magnitude at t equal to 0. Okay. हो गया? ये तो है. What is the strength? Infinite. But exactly at what? 0. And that's why it is called infinite signal. Okay. Now it is clear. So capacitor allow sudden change of voltage for infinite current, and inductor allow sudden change of, capacitor allow sudden change of voltage for infinite current, inductor allow sudden change of current for infinite voltage. लिख देते भाई, कुछ कंफ्यूज नहीं होना. Capacitor allow sudden change of voltage for infinite or impulsive current. Infinite or impulsive current. Similarly, inductor allow sudden change of current for infinite or impulsive voltage to satisfy what? KCL and or KVL. Next one. चलिए इसका आंसर बता दो. अब तो बता दो. This is a very easy. Right. Always remember, we are making silly mistakes in what? During solving easy questions. Right. So be careful, read question carefully and give me the answer. Means what is the question, sir? It is the question from measurement. Which voltage source? Which voltmeter you want? 2 voltmeter? देखो एक तो क्वेश्चन आ रहा है मेजरमेंट का, अलग अलग टाइप के वोल्ट मीटर. इफ नॉर्मली इन सर्किट थ्योरी वी आर यूजिंग दैट वोल्ट मीटर, so if you have the DC voltmeter it will measure what DC value of that. If you have the normal voltmeter that will read what RMS value of, है ना. ओके उल्टा ही गया, समझ गए ना. तो ये तो ठीक तो लिखा था, अब कुछ गलत उल्टा तो नहीं लिख दिया ना मैंने, सही तो लिखा है. फाइनल कैपेसिटर अलाउ सडन चेंज ऑफ वोल्टेज फॉर इनफाइनाइट करंट, इंडक्टर अलाउ सडन चेंज ऑफ करंट फॉर इनफाइनाइट वोल्टेज. ये बड़ा तकलीफ है. बताओ भाई जल्दी जल्दी, अभी बहुत अभी चलेगा 1-1.5 घंटा, और बहुत सारी चीज़ें और भी डिस्कस करनी है अभी आप लोगों के साथ में. यस प्लीज़. अब आ जाओ. दैट इज इन द नेटवर्क द स्विच के इज क्लोज्ड एट t इक्वल टू 0 विद 0 कैपेसिटर वोल्टेज एंड 0 इंडक्टर करंट. इनिशियली unenergized, this is unenergized. After solving that question, this will be very easy for you. What will be the answer? Right, what will be the answer for this question? In the network the switch K is closed at t equal to 0 with 0 capacitor voltage and 0 inductor current. Find the value of V1 and V2 at t equal to infinite. Now read question carefully. It is not the question on initial condition, it is the question on what? Final value at t equal to infinite. What about this source? It is a DC source, right? And V voltage is given, R1 and R2 is given. So finally, okay, number of students here you are giving the answer A, Calvin C, Mani C, right? Again, okay, so be careful, already I have given, right? To respectively means what? First of all you have to give the value of V1 and then what? V2. V1 means voltage across the inductor, V2 means voltage across the resistor. Very easy question. Finally at t equal to infinite, this is the V volt. This capacitor will act as what? Open circuit. This inductor will act as short circuit, and this is the R2, this is the V1, and that is what? V2. V2 means voltage across the resistor. What? V1 will be 0, and what is the V2? According to voltage division rule, R2 divided by R1 plus R2 into what? V. So R2 divided by R1 plus R2 into V. Okay, so that is the very simple question. Okay, next one. ये भी आएंगे. पहला वाला हमने और कॉन्सेप्चुअल क्वेश्चन डिस्कस कर लिया. अब बताइए जरा. ओके, रीड क्वेश्चन केयरफुली. Here in a GATE exam last year, what about the 1 marks question or 2 marks question? First of all 1 marks, then 2 marks, or jumbled mixed question. One question, first question may be from 1 marks, second question may be of 2 marks, right? Third questions may be based on what? MSQ. Fourth question may be what? Numerical answer type. Fourth question MCQ, 2 marks, then again 1 marks, that is jumbled, right? So we are getting the tough question, then easy questions, then what? Tough, then easy, 2 marks, 1 marks, and that is the pattern. Remember this, right? So some students are planning that first of all I will solve 1 marks question, then I will go forward 2 marks question, I will start from last, I will start from the first. So simply, okay. बोले जरा, अगर ये मेरा वर्किंग, रुक जाओ, बोले जरा क्या होगा आंसर भाई? These are the RMS value. तो चलिए इसको भी डिस्कस कर लेंगे. आई विल गिव द आइडिया अबाउट व्हाट फेजर. ओके कुमार, दैट इज व्हाट यू हैव टू फाइंड द एंगल बिटवीन व्हाट there will be a current, that current will pass in series, the current will remain same, and what is the phase difference between that current and what voltage is. That is the, you have to find that value, and the resultant value is what voltage across that branch and voltage across that. Okay, just wait for that. Okay everyone, first of all, what is the answer for this question? The rating of each lamp. तो जो आपने इसके हम आंसर भेजा है ना, सिंपली इन सीरीज द करंट विल रिमेन सेम, राइट, बट दैट इज व्हाट यू हैव टू कैलकुलेट द फेजर सम. द फेजर सम ऑफ व्हाट V1 and V2 is given as what the value. Then you can find the value, that is the relation you can find, and then you can find the angle between what V1 and V2. But you have to find what angle between the applied voltage and current, that is called, and calculate the cos theta, that is called power factor. Okay, okay. Now what is the answer? 200 watt. Okay, so rating of the each lamp is 100 volt, 100 watt, and if the switch S1 is open, S2 is closed, then power given by the battery is, right. Watch this question carefully, watch this question carefully. Open circuit, this switch is open, this switch is closed, right. This is the lamp L1, and what is the rating? 100 volt. What is the power? 100 watt. What is the rating? 100 volt. What is the power? 100 watt. Means these two are all are identical. 100 volt, 100 watt power rating. 100 volt, 100 watt is the power rating, but this is the short circuit. So what about the current? Current will flow like this, and this is the 200 volt, so resistance will remain same. No need to calculate the resistance, otherwise you can calculate the resistance. What is the power is equal to V square by R. What is the R is equal to V square by P. You can also calculate the resistor, but no need to calculate the resistance. No need to calculate the resistance. Simply the voltage across this lamp is 100 volt, voltage across this lamp is 100 volt. So 100 and 100. So what is the value? It will consume 100 watt power, it will consume 100 watt power. So what is the power given by this battery? 200 watt. The power given by the battery is 200 watt. Why? Because it works on what? It's given rating. 100 volt is here, 100 volt is here, and it will consume 100 watt, it will consume 100 watt. What is the power consumed by this lamp? 0, because it is short circuited. Voltage across this lamp is 0. Easy? तो क्वेश्चन बहुत ही इजी था, बस कंफ्यूज नहीं होना. This is a very easy question. Next one. Tell me the number of independent KVL and KCL equation for a network with 9 nodes and 12 links are respectively. Sometimes a 1 marks question, in between what 2 marks question. So if we are solving question on what initial condition, it will be of what 2 marks, or if normal KCL and KVL, then it is of what 1 marks question. Okay, जितने भी लोग हैं एक बार जरा भाई लाइक जरूर कर लीजिएगा इस सेशन को. ओके, धीर, इफ देयर वर अ 300 वोल्ट बैटरी देन डैमेज नहीं, वो पावर आउटपुट इज व्हाट डायरेक्टली प्रोपोर्शनल टू द वोल्टेज, बट द रजिस्टर विल रिमेन कांस्टेंट. So if we are giving the 300 volt, so voltage provided to both the bulbs will be what? Increase, 150 volt bulb. So what about the brightness? Will increase, power output will be more. That is the case. Power output will be more. If it is more than the what we are giving the rating, the brightness will increase. But what is the maximum power handling capacity of the bulb? If it will cross that capacity, then definitely it will damage the bulb. Okay, so yes, we can say the number of independent KVL and what KCL equation for the network with 9 nodes and 12 links. So देखिए, always KVL means what? How many KVL is possible? Number of links. The number of links is what? 12. Or how many KCL? KCL means what? Always n minus 1. n minus 1 because one node is what reference node. One node is what reference node, right? We are writing the KCL means what? How many KCL and KVL equation? So we are writing the these are the nodes, right? If I am having this node, so how many nodes? One. This is the reference node. 1, 2. So how many equations? Only we have to write one equation. 2 minus 1. That is what? N minus 1. Okay? This is clear? Remember this equation, number of branch is equal to what? B is equal to. We are writing, no sorry, number of links. L is equal to B minus N plus 1. This is the number of links. From the graph theory, that is the formula. Where L is what? Links. B is the number of total branch, N is the number of nodes. So this is the equation. We can find what? L if the total number of branch is given in the circuit. Total number of branch is given in the circuit, then you can use this formula. So I think this is also clear to you. Then next question. This one. This is very, very important one. On initial condition. In the circuit of figure, calculate the dVR by dt 0 plus. dVR by, again it is of 2 marks. Again it is of 2 marks. Yes please. बताइए क्या होगा यार? एक बार ये लाइक को बताइए, आपने 99 में हटा दिया। तेंदुलकर हर बार 99 में आउट हो जाता था, राइट? सेंचुरी होगी या नहीं होगी ये बताइए, राइट? देखा था ना, नर्वस 90 जिसको बोलते हैं। तेंदुलकर, सचिन तेंदुलकर भी बहुत लंबे समय तक नर्वस 90 का शिकार हो गया। तो नर्वस 90 का मतलब है 90 से 100 बनाने में कई बच्चे क्रिकेटर आउट हो जाते थे। तो दैट इज कॉल्ड व्हाट? नर्वस 90 सिंड्रोम। तो नर्वस 90 सिंड्रोम, तो तेंदुलकर सफरिंग फ्रॉम दैट। तो बहुत सारी बार ना 90 से ऊपर रन बनाया लेकिन 100 कवर नहीं कर पाया। ऐसे कितने लोग परेशान हैं बताइए सर? हाउ मेनी स्टूडेंट्स सफरिंग फ्रॉम दिस? मतलब यू आर गेटिंग द गुड मार्क्स इन मॉक टेस्ट, राइट? और आपको 5th and 6th Feb एंड इन फर्स्ट वीक ऑफ द फेब यू हैव टू गिव द फाइनल एग्जाम। तो नर्वस नहीं होना है, पूरा परफॉर्म करना है, पूरे क्वेश्चंस बनाना है, पूरे कॉन्फिडेंस के साथ बनाना है। वहाँ जाके अपने नेचुरल टैलेंट को बना कर रखिएगा, क्योंकि वो एक बार देना है, साल भर में एक बार होता है, तो बहुत ही मेंटल प्रेशर होता है, मुझे पता है। उसको बिल्कुल भी घबराना नहीं है, राइट? यस, टेलीग्राम ग्रुप ऑलरेडी आई हैव अपलोडेड द लिंक ऑफ दैट टेलीग्राम ग्रुप। ओके, तो समझ में आई बात? ये देखिए, अब मेरे 102 रन हो गए, मैं तो नर्वस 90 का शिकार नहीं हूँ। ये क्लियर हो गया आप लोग को? ऑलवेज रिमेंबर दिस। एक बार जरा फटाफट आप लोग सब लाइक भी कर लीजिएगा और इस बात को ध्यान रखिएगा, जब एग्जाम को आप करने मारने का प्रश्न बना लोगे ना, अरे मेरी तो अगर गेट नहीं हुआ तो मेरी तो जिंदगी खत्म हो गई, तब फिर आपसे नेचुरल टैलेंट से आप क्वेश्चन नहीं बना पाओगे। आप ये समझो कि आपके लिए गेट एग्जाम कोई मायने नहीं रखता। मतलब मायने रखता है, सिंसियरली पढ़ना है, मतलब मैं बोल रहा हूँ कि मायने नहीं रखता, तो आप आराम से दीजिए। सेकंड इंपॉर्टेंट थिंग, जस्ट ऑलवेज रिमेंबर वन थिंग। एक बात बताओ, भगवान के घर में कौन कौन जाएगा? कौन कौन टेंपल में जाने वाला है? यस और नो? मंदिर में लास्ट में अपने अपने इष्ट देवता, मंदिर, मस्जिद, गुरुद्वारे, चर्च, सब जाओगे कि नहीं जाओगे? लास्ट में ये बताओ। नहीं जाओगे? मतलब घर में जाओगे कि नहीं जाओगे? कितने लोग नास्तिक हैं मतलब, राइट? यस और नो? फाइनली जाओगे कि नहीं जाओगे? जाओगे ना भाई? हाथ जोड़, भगवान आज का पेपर अच्छा आना चाहिए, मेरा D-Day होना चाहिए, मेरे लायक क्वेश्चन आना चाहिए, राइट? सब कुछ मुझे याद आ जाए, ऐसा होगा कि नहीं होगा? मैं तो जाता था भाई लास्ट मोमेंट पे, तो वही है सहारा, राइट? और किसी को तो साथ ले जा नहीं सकते, ना पेरेंट्स जाते ना दोस्त जाते। वर्चुअल कैलकुलेटर भी वहाँ से मिलेगा, ट्रिबल पैड भी वहाँ से ही मिलने वाला है, तो अब किसको साथ ले जाए? एक ही बचा। अब आप उसको क्या करोगे? लास्ट दिन नारियल चढ़ा दोगे, राइट? और बोलोगे चलो हमारे साथ। ऐसे थोड़ी नहीं जाएंगे। आपको रोज मिनिमम 15 मिनट्स के लिए उनको ध्यान लगाना होगा। तो मेडिटेशन कीजिए रोज 15 डेज और उनसे रिक्वेस्ट कीजिए कि भगवान मेरे साथ चलिए आप, तो वो आपके साथ जाएंगे। समझ में आ रही बात? मतलब रोज 15 डेज आपको क्या, 15 मिनट्स के लिए आपको क्या करना है? थोड़ा ध्यान लगाइए। उससे क्या होगा? एक आपको कॉन्फिडेंस आएगा, मेंटल सपोर्ट मिलेगा, एक साइकोलॉजिकल ये आएगा कि हाँ मेरे साथ कोई जाने वाला है। और जब आपको कॉन्फिडेंस आएगा ना, वही तो सब खेल है भाई, वही तो सब खेल है। पूरा एग्जाम में आप बहुत अच्छे से परफॉर्म कर पाओगे। भगवान होते हैं, किसने कहा नहीं होते? भगवान है ना, लेकिन ऐसा थोड़ी ना, इतने भी बच्चे नहीं है मतलब तुम बोलोगे और तुम्हारे साथ चलिए, थोड़ा बहुत तो मस्काबाजी करना पड़ेगा ना, मतलब ढंग से, ऐसा नहीं कि लास्ट मोमेंट पे। आज से स्टार्ट कीजिए, जब आपको मन करता है तब से स्टार्ट कीजिए, मॉर्निंग से स्टार्ट को ध्यान लगाइए। और ऐसा मत सोचो कि इतने बेवकूफ़ हैं कि मतलब तुम बोले और चले तुम्हारे साथ, ऐसा नहीं होता। 15 दिन कम से कम बताओ यार, इस 15 दिन में ज़रूरत है उनकी हमको, राइट। तो देखिए मेरी तो प्रैक्टिस है, मेडिटेशन से क्या होगा, कंट्रोल हो जाएगी, पूरी एनर्जी को आप कॉन्सेंट्रेट कर पाएंगे, राइट। और जब एनर्जी कॉन्सेंट्रेट रहेगी ना, तो ये 7-8 दिन में कुछ होना जाना नहीं है। ये रिवीजन करो, फॉर्मूला पढ़ो, मॉक टेस्ट दीजिए, फ्री रहिए और कूल रहिए, ठीक है। फिर कैसे एग्जाम करते हो, ठीक है, ओके। अब चलिए आ जाओ, चलो सबके सब। नाउ दैट इज वेरी वेरी इंपॉर्टेंट क्वेश्चन। इन द सर्किट ऑफ द फिगर कैलकुलेट द dVr by dt 0 positive. Normally we are saying that we have to calculate what? di by dt 0 positive. What is this? This is the current through the inductor, dv by dt 0 positive. This is normally the current through voltage across the capacitor, but new thing asked here, dvr by dt 0 positive, dvr by dt 0 positive. Okay, how we can calculate? This is the V voltage. We have to find the change. This is the 3 ut. It is visible to you, yes or no? Lekin it is a 3 ut. Okay, no problem. This is the 3 ut. So first of all, what is the meaning of the 3 ut? Here no switch is given. No switch is given. This is very 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 important question, sir, right? So no switch is given means what? Okay, one answer by the Kisan. Okay, B option. I will check. 3 ut means what? This is the 3 for t greater than 0 and this is 0 for t less than 0. It is a unit step signal. So 3 ut, this is the step signal 3, right? So there is a sudden change. If there is a sudden change, what is the nature of inductor and capacitor? They does not allow sudden change of voltage and one does not allow sudden change of current. That is the value. So step signal act like what? Switch. Act like what? Switch. This is the time. This is the 3 volt, and this is the t less than 0, and this is t greater than 0. ठीक है, अब देखिए. Now second one, how we can calculate this? First of all, this is the 3. For always remember, when we want to calculate the dVr by dt 0 plus, always go for what? T0 negative. What is the position at T0 negative? So if that is the diagram, that is the diagram. Now for T0 negative, circuit will be in steady state. T0 negative, circuit is in steady state, and this is the DC value, this is the DC, this is also DC. For t less than 0, it will act as what? Open circuit, because it is a current source. To make it open circuit, so simply make it open circuit. This is the act as what? Open circuit. Remove this current source. Now what is the nature of the capacitor? Capacitor will act as what? Open circuit under steady state. So this will act as open circuit. What is the inductor? Inductor will act as short circuit. This is a 20 volt battery, right? Now that is the case. Try to understand. This current source will act as open circuit, 20 volt battery and IL. So what is the current through the inductor? Write down the voltage at this point, because this will act as open circuit. There is no branch, so IL0 negative. IL0 negative is equal to IL0 positive is equal to what? 0 ampere initial current. And what is the VC plus 20? VC plus 20 is equal to 0. So what is the VC is equal to minus 20 volt. That is the initial voltage across the inductor and voltage across the capacitor and inductor. I think this is clear to you, everyone. So capacitor will act as open circuit. This current source will act as open circuit. This is the 20 volt. This is the value. Total 20 volt will come across this, because this will act as short circuit. So what is the voltage at this point? It will be 0. So I am writing the equation that is equal to V. V is nothing but VC plus 20 volt, because this branch will act as short circuit. this voltage will become 0. So what is the voltage? VC minus 20 volt. What is the current here? 0. What is the current here? 0. What is the current in this branch? 0. Everything is 0. Now IL0 negative is equal to what? IL0 positive is equal to 0. VC0 negative is equal to what? VC0 positive is equal to what? 0. But we can't write, always remember, we can't write this. Right? Why? Because resistor allow the sudden change of voltage as well as allow the sudden change of what? Current. Always remember this. It will allow the sudden change of voltage and it will allow the sudden change of current. That's why we can't find the value of VR. Now, exactly at t equal to 0 plus, this is the diagram. Exactly at t equal to 0 plus, this is the 3 ut. This current is what? 3 ut. Now for 0 plus it is the 3 ampere. Now what is the initially the voltage across the capacitor? Remember this. This is the minus 20 volt. VC 0 plus minus 20 volt. Right. Now what is the voltage at this point? Because it is a minus 20 volt, this is the plus 20 volt. The initial voltage at this point, that it is the Vx is equal to 0, right? Because Vx is equal to Vc 0 plus 20, that will become 0. Voltage at this point is 0. Now watch this, voltage at this point is also 0. Voltage at this point is also 0. This is 0, that is 0, right? What will be the current? We can apply the current division rule. So what is the current here? The current here is I1, the current here is I2. So we can find the current here. We can find the current here. What will be the current here? Now if it is required, then we can find the current here. What is the current according? Because this voltage is 0, that voltage is 0, we can apply the current division rule. If this voltage is not 0, we can't apply the current division rule. Always remember, we can apply the current division rule when the two resistors are in parallel. And when the two resistors are in parallel, when voltage across that two resistors are equal. Give me the answer. What is the answer for this question? Everyone. That is very, very important. Okay, no problem. Now it is audible, everyone. This is audible. Yes, please. It is audible now. ऑडिबल है ना अब? हाँ देखो यहाँ पर if we want to divide the current, always remember, if you want to divide the current, then resistors should be in parallel. And when two resistors are in parallel, when the voltage across that resistor are equal, right, then we can apply the current division rule. And when we are applying the current division rule, so according to that, the voltage across that 1 ohm resistor, 2 ohm resistor is what? 2 ampere, and 4 ohm resistor is what? 1 ampere. What will be the voltage then? Voltage is what? Voltage is just equal to 4 volt. Now, but it is not required. It is not required in the question. Just I am giving you which type of questions they may ask. They may ask on this particular diagram. Okay. अब देखिए. Second thing, what is the dVc by dt? It may is required. So what is the initial current through the inductor? It is 0. So this 1 milliampere current will flow through the capacitor only. So always remember, IC0 negative, IC0 positive is given by C dVc by dt 0 positive. If any question dVc by dt is required, this will become IC0 plus divided by what? C. IC0 plus divided by what? C. What is the IC0 plus divided by C? IC0 plus divided by C is 1 ampere divided by what? What is the value of the C given in the question? 1/2 farad. 1/2 farad. This will become 2 volt per second. This will become 2 volt per second. Right? It is clear. I think that 2 questions are clear. एक आप लोगों के लिए announcement भी है that I am having the class on what Tuesday 8 PM on MCQ. Already I have given you the idea about that. I will share the link with you. Please join my Telegram channel. Okay. और ये नंबर कम मत करो भाई, बने रहो, अभी बहुत सारे क्वेश्चंस आने वाले. Okay. Now so dVc by dt 0 plus is equal to what? 2 volt per second. Now what is required here? Actually the requirement is of what? Or what is the voltage across the inductor? The voltage across the inductor is 0. So initial voltage across the inductor is given by L di by dt 0 is equal to what? 0. This is the voltage across the inductor, and that's why the initial value of dIL by dt 0 plus, it will become what? 0. Initial current through the inductor is 0, and the rate of change of the current through the inductor is also 0. Why 0? Because that voltage is 0. No doubt, inductor allows the sudden change of voltage, but initial voltage is 0, and that's why we are getting this value. Last point, last one, what is required here? But in the question, required is what? dVr by dt 0 plus. dVr by dt 0 plus. If this is required, then this voltage is required. Always remember, voltage at this point, you have to write the general answer. You have to write the general answer at this point. The voltage at this point is nothing but Vc plus 20 volt. This is the 20 volt, this is the Vc, Vc plus 20 volt, right? And voltage at this point is what? Vr. Voltage at this point is what? Vr. What is the incoming current, everyone? Tell me, what is the incoming current? 3 volt, 3 ampere. Write down the KCL at this point. Incoming current is 3. What is the outgoing current? Vr by 2. Vr by 2 plus what? Vr minus Vc plus 20 divided by what? 4. Directly you can write this. Now this is the formula. You can take 4 as the LCM. It will become 12. This will become 2Vr plus Vr minus Vc minus 20. Yes or no? Now you can write 32 is equal to 2Vr plus what? 3Vr plus minus Vc. 3VR minus what? VC. That is the equation, general equation. I am writing this KCL at this point. Now differentiate it. Differentiate equation with respect to t. 0, 3 dVR by dt minus what? dVc by dt. So what is the dVR by dt? 0 plus, everyone. That is nothing but 1 by 3 dVc by dt. What is the dVc by dt here? dVc by dt is what? 2. dVc by dt is what? 2. So what is the answer here? 2 by 3 volt per second. Volt per second. So that is the answer. So in this way you can find the value. This is very, very important question. 2 marks. No doubt it will take around 2 to 3 minutes in exam hall, but no problem. This type of question they may ask. Okay, 1 minute. Right. Any doubt, then you can ask. I think up to this point everything is clear. No. अब ये आप लोगों के लिए एक असाइनमेंट है, फिर उसके बाद और भी क्वेश्चन डिस्कस करते हैं. डिटरमाइन द एनर्जी in microjoule delivered by the voltage source from t equal to 0 to t equal to 3 in the figure. The inductor current I is 0 at t equal to 0. The initial current through the inductor is what? Initially 0, right? It will act as what? Open circuit initially because there is no current through the inductor. Now watch this diagram. 5 volt I1t. So 5 volt will remain same, right? 5 volt will remain same. And what is the diagram for I1? This is the diagram. What is the given? Determine the energy delivered by the voltage source from t equal to 0 to t equal to 3 in the figure. So t equal to 0 to t equal to 3. What will be the energy given by this source? So that is the current given by this battery. Always remember, if the current is then 1, so energy is given is what? Energy is given as 5 into what? I. This is the power. This is what? Power. You have to integrate it from 0 to what? 3 dt. Now you have to get the equation of I. That is the function of time. That is the function of time it. And what will be the current here? It minus I1t. I1t. Initially, what will be the current through the inductor? It will be what? 0, because it does not allow sudden change of what? Current. So it will be 0, and then that is the current it, I1t minus I1t, and get the equation right. And then finally you can find up to what? 0 to 3. It is a variable. Up to 3 you have to find the energy. That is the assignment for you. I will solve it for you. Then अब कुछ और देखते हैं. क्वेश्चन जरा और निकालें. क्या है क्वेश्चंस का वेरिएशन? यस. अब आते हैं जरा फेजर पर. राइट, जैसे कि एक ने क्वेश्चन भी पूछा था. पहले तो आप ये बताइए, डिटरमाइन द इंडक्टर करंट IT फॉर बोथ t less than 0 and for t greater than 0 for the given circuit in the figure. For t less than 0 and for t greater than 0, what will be the current? Right. हाँ धीर, आंसर मैं दे देता हूँ. बताइए जरा क्या होगा. One minute. What will be the answer for this question? हाँ, the answer for the previous question is what? 51 to 51.5. 51 to 51.5 प्रीवियस ईयर क्वेश्चन आप बना सकते हैं कॉन्सेप्ट यूज के. इफ यू वांट सॉल्यूशन देन ऑन टेलीग्राम चैनल आई विल गिव द सॉल्यूशन फॉर दैट, डोंट वरी. देन try that question, okay, no problem. Then 51 to 51.5, okay. तो ये है, दैट इज व्हाट ट्रिक्स टू हैंडल द एमसीक्यूज इन गेट स्ट्रैटेजी टू मैक्सिमाइज द मार्क्स, राइट. तो ये है, दिस इज द एमसीक्यूज एंड I will give you what complete strategy how to handle what MCQs, multiple choice questions in competitive exams. If you are able to solve what 2 to 3 extra questions by using calculated risk or by using elimination method and number of method to solve what MCQs, okay, so that is the session for you. If you want to increase your marks, if you want to calculate take some calculated risk, it's up to you, it's up to you. It is advisable, तो फोर्सफुली नहीं है, राइट. इफ यू वांट टू टेक सम कैलकुलेटेड रिस्क तो आप आ सकते हैं, आपके ऊपर है, आपकी चॉइस है कि आप इसे लेते हैं या बनाते हैं या नहीं बनाते. बट रिमेंबर दैट इफ वी आर टेकिंग द कैलकुलेटेड रिस्क वी कैन इंक्रीज आवर मार्क्स बाय व्हाट, अप टू व्हाट, बाय 6 और बाय 10 इन गेट एग्जाम, ओके. तो ये है. अब आते हैं जरा 1 मिनट. Yes, you are giving the answer for this question is what? D. Yes, always remember exactly at t equal to 0 the switch is open. Now it will become what? Source free. Determine the current inductor for both for t less than 0 and for t greater than 0. Always remember, for t less than 0 means t0 negative. Circuit is in steady state, switch is closed. Inductor will act as what? Inductor will act as short circuit. The 6 ampere will pass through the inductor. So what is the initial current through the inductor? I0 negative is equal to what? I0 positive is equal to what? 6 ampere. 6 ampere, because this inductor will act as short circuit exactly at 0 negative. Always remember, circuit will be in steady state and this is the DC current. For DC, inductor will act as what? Short circuit. Second thing, what is the equation? Now after t greater than 0, this will become, this will 2 ohm and that is the inductor, that is what? 3 Henry and this is the 2 ohm only. So what is the time constant of this circuit? L by R, that is nothing but 3 by 2 second. Always remember, we are calculating the time constant for what? T greater than 0. So this is the 3 by 2. What is the final current? 0. Why final current 0? Because it is a source free circuit. So we can use this formula. IT is equal to I final minus I final minus I initial e raised to power minus t by tau. What is the final value of the current? Final value of the current is what? 0 minus 0. What is the initial value? 6 e raised to power minus t by 3 by 2. What is the answer? 6 e raised to power minus 2 by 3 t. Exponentially decreasing function, what is the response? That is the response. Now we are having this value for t less than 0, that is represented by this, and after that exponentially decreasing function. This is initial current, this is the IT, this is the time, that is 0. This is for t less than 0, this is for t greater than 0. Exponentially decreasing function. Okay, so they may ask what curve, they may ask what initial value, final value, अंडर स्टडी स्टेट, टाइम कांस्टेंट। ओके भाई अब गायब मत होइए, अभी और भी क्वेश्चन है, 2-3 और क्वेश्चन डिस्कस करते हैं, उसके बाद ये सेशन हो जाएगा। अभी देखते हैं जरा एक और जो क्वेश्चन आपका नॉर्मली जो इस पॉइंट पर आता है वो है ऑन इनिशियल कंडीशन। ये देखिए सर, in the circuit the switch moves from position A to position B at t equal to 0, find the IT for t greater than 0। देखिए ये तो अगेन बहुत ही दैट इज अ वेरी वेरी बेसिक क्वेश्चन। what is the switch move from position A to what position B at t equal to 0, find the IT for t greater than 0। so if it is initially connected here, the complete current will pass through the inductor, the complete current will pass through the inductor। So what is the I0 negative is equal to I0 positive is equal to what? I naught। In GATE exam they will give the numerical value, let it is a 2 ampere, let it is what 1 ohm, let it is what 2 Henry, and let this is the 10 volt, 10 volt battery, that is the numerical value। So I0 negative is equal to I0 positive is equal to I naught, let it is 2 ampere, right? Now the for t greater than 0, this switch is connected here, this switch is connected here, that is the circuit। So that is the circuit for t greater than 0, what will be the time constant? L by R, that is nothing but 2 seconds। What is the final value of the current? I infinite, this will become 10 minus it will act as short circuit, 10 by 1, 10 ampere। We have the initial value of the current, we have the final value of the current. What will be the equation? I0 negative, sorry, IT is equal to I infinite minus I infinite minus I0 e raised to power minus t by tau। So that is the question from what? Standard textbook। Then in GATE exam they will provide you what? Numerical data, right? So this will become very easy for you। So what is the answer here? This is the 2 ampere, that is the 10 volt। IT is equal to I infinite. What is the infinite? Infinite current is 10 ampere, 10 ampere, initial current is 2 e raised to power minus t by 2, because the time constant is 2, 10 minus 8 e raised to power minus 0.5 t। This is valid for t greater than 0। So this type of questions in competitive exams, but one more important question on initial condition। So I think any doubt in this question? It is about what? Inductor। It is about what? Inductor। Normally in electronics we are getting the question from what? Capacitor। Yes, what is the doubt here? You have any doubt? Then yes, you can ask। Because initially the inductor is connected here, the I naught, the 2 ampere current will pass through the inductor, right? Then this is the 2 ampere current। Second thing, once this switch is moved from what? A to B, what is the voltage? V naught, final current, finally the inductor will act as short circuit, that is the 10 by 1, 10 ampere। We have the initial current, we have the final current, we have the time constant, and directly you can use this formula। Okay, what is, you have doubt, what is the inductor means? What is the doubt here? अच्छा, आप इंडक्टर की डेफिनेशन पूछ रहे हैं, तो ठीक है, पूरे बहुत ही बेसिक में जाकर पढ़ेंगे बाद में। ओके, वैल्यू ऑफ द इंडक्टर इज व्हाट? 2 हेनरी, एंड इट इज अ एनर्जी स्टोरिंग एलिमेंट, राइट? नाउ दिस इज द क्वेश्चन, this is the question। In this question, number of objective on this diagram। In the network, let V10 is 2 volt। V10 means what is the voltage at this point? V10, this is the C1, this is the V20, this is the C2, and this is the R, this is the value of R, right? V10 is given, V2 is given, R is given, C1 is given, C2 is given, at t equal to 0 the switch K is closed। बताइए, what is the initial value of I and what is the equation for the I? Everyone, this is the very very important questions, number of objective question in this diagram. This is the quick revision of network, right? एक बार जरा यार फिर से आप लाइक सब्सक्राइब शेयर कर लीजिए, फिर देखिए जरा. Okay then. So first of all, this is a very general question, very very general and important question. V2 initial value is given, right? R is given, C1 is given. How we can solve? Always remember, capacitor does not allow sudden change of what voltage. So for this particular diagram, this voltage V1 0 is equal to 1 volt, 2 volt is given, V2 0, 1 volt is given, initial voltage. This is the capacitor. This switch is closed for t equal to 0. R is given as 1 ohm, C1 1 farad, C2 1 by 2. 1 farad, 1 by 2 farad, 1 ohm resistor, it is given. When we are closing the switch, what is the initial current? Yes, here now it is visible. Now it is visible, this circuit is visible, right? So initially, when we are closing the switch, this is the diagram. I think now it is visible. Right. So what is the initial current? Always remember the initial current I0 plus is equal to V1 0 plus minus V2 0 plus divided by what R? This is nothing but 2 minus 1 divided by 1 ampere. This is the initial current. If this voltage is 2 volt, that voltage is 1 volt, 2 minus 1 divided by R, that is the 1 ampere is the initial current. Always remember, that is the first objective. Second, what is the time constant of this circuit? So these two capacitors are in series. Watch this diagram. These two capacitors are in series. So what is the time constant of this circuit? RC equivalent. R C1 C2 divided by what? C1 plus C2. Because these two resistors are, these two capacitors are in series. So what is the series combination of this? So C equivalent will become 1 into 1 by 2 upon what? 1 plus 1 by 2. 2 to cancel, 1 divided by what? 3 second. 1 divided by 3 second. What will be the final? It is a energy, because there is a no extra independent source are available. What will be the final voltage across the capacitor, everyone? What will be the final voltage across the capacitor? Tell me for this question, because there is no independent sources are available here. That is the capacitor. Here you have idea about that. What will be the final voltage across the capacitor? This is the V2. The switch is closed. 1 ohm resistor. This is the C1. Yes. Now, the final voltage across the, if you want the final voltage across both the capacitor, it is a source free because there is no external source. Always remember, finally, we are saying that capacitor act as what? Open circuit. What is the meaning of this? Capacitor act as open circuit means current will become 0. Current will become 0. So initially the current voltage across this capacitor is what? 2 volt. This capacitor is 1 volt. 2 minus 1. Current flows from higher voltage to lower voltage. So this is the direction of the current. But finally this capacitor will discharge and this will charge. The final voltage across both the capacitor will be equal. Final voltage across both the capacitor will be equal. But in this capacitor voltage will be less than 2, or here it will be greater than 1. Always remember, it will discharge, it will charge. it is less than 2, it will be greater than 1. Both will be equal. So at t equal to infinite, this voltage will be V infinite and this voltage will be also V infinite. Both will be equal and the current will be 0. At infinity the current will be 0. Now what will be the value of the voltage at infinity? So to find the value of the infinity, charge. Always remember, there will be a law of conservation of charge. Charge can neither be created nor be destroyed. So final charge and initial charge will remain same. So Q infinite is equal to what? Q0. What is the Q infinite? C1 V infinite, because voltage will remain same, plus C2 V infinite. What is the initial voltage across the capacitor? C1 V10 plus what? C2 V20. So for this diagram, always remember the general formula. Infinite voltage is given by C1 V10 plus C2 V20, means initial value, upon what? C1 plus C2. C1 plus C2. So in this case, this value is what? 1 farad into 2 volt plus 1 by 2 into what? 1 volt divided by 1 plus 1 by 2. Tell me what will be the answer. So this will become 4 plus 1, 5, 2, 2 cancel, 5 by 3. Five by 3. How many students gave the answer for this question? Sir, it is a very general question. Give me the answer. General means important, but you have idea about that. So if you have no idea, then please remember this. So finally the voltage across this capacitor and this capacitor will equal, and this value is given by, according to law of conservation of charge, Q infinite is equal to Q0, C1 V infinite, C2 V infinite, C1 V10 plus C2 V20, and that is the answer, 5 by 3 volt. It is the final voltage. Final voltage, right? Okay, yes, right. Now finally watch this. Now in this diagram, if you want to calculate the current, voltage, always we can use this formula. Vt is equal to what? V infinite minus V infinite minus V0 e raised to power minus t by what? Tau. तो यहाँ पर पॉइंट आ गया V infinite, right? अगर आप we want to calculate the V1, तो what is the infinite value? 5 by 3. What is the infinite value? 5 by 3. What is the initial value? 2 volt minus t. What is the time constant? Already we have calculated. What is the time constant of this circuit? C equivalent is 1 by 3. So RC equivalent, R is equal to 1 into 1 by 3. That is what? 1 by 3 second. It is the time constant. 1 by 3 second is the time constant. Then you can use this time constant, 1 by 3. This will become 5 by 3 minus minus, it will become plus. This is the 1 by 3 e raised to power minus 3t. That is the answer for V1. What is the answer for the V2? What is the final value? 5 by 3. What is the minus 5 by 3? What is the initial value? 1 volt e raised to power minus t by 1 by 3. What is the answer? 5 by 3 minus 2 by 3. 5 by 3 minus 2 by 3 e raised to power minus 3t. 5 by 3 minus 2 by 3 e raised to power minus 3t. Right? Sir, what is the answer if the any voltage source is present in series means what? If any voltage source is present in series, that is called what? Forcing function. Yes, Kumar. That is called what? Forcing function. Forcing function means what? Capacitor will charge. 5 by 3 minus 2 by 3 e raised to power minus 3t. That is the answer. Now finally, what is the current? Current is given by I finite minus what? I finite minus I0 e raised to power minus t by tau. What will be the value? It is equal to I finite. What is the value? 0, 0 minus what is the initial value of the voltage, 1 volt, e raised to power minus 3t. Put the value tau is equal to 1 by 3. It will become e raised to power minus 3t. So that is the answer, but draw the diagram. If it is possible, then draw the diagram. What is the initial voltage? 2 volt. What is the final voltage? 5 by 3. This is the 5 by 3. So first of all, this capacitor will discharge. This is the V1T. Initial voltage is 2 volt and then final voltage is 5 by 3 volt. What about the second one? Now watch this. Initial voltage is 1 volt, final voltage is what? 5 by 3 volt. So first of all, this is the 1 volt, now this is charge. Towards what? 5 by 3. This is the VT, V2T. One increasing and one what? Decreasing. The diagram is clear to you? This diagram is clear to you? Acha, Q infinite is equal to Q0 means in this diagram, this is because this is connected in series, the same charge will flow, right? Initially the charge will be stored in the capacitor, right? That charge will pass through this, again this capacitor will charge, so the charge will remain same in this series diagram. Okay, that is the concept. Okay, now finally what is the watch this diagram. What is the current? Current initially it is 0, but capacitor allow the sudden change of current. So suddenly what will happen? This is the 0 current. Suddenly it will rise to what? 1 ampere. Now it will discharge. इसे बोलते हैं that is the representation in all time. What is the given in the question? Represent in all time. So this is the all time. For t less than 0 it is 0. Suddenly there is a sudden change and now it will discharge. But there is no discontinuity. 2 volt, then it will decrease. 1 volt, then it will increase. That is called for all time. That will be the diagram. I think this is clear to you. Okay, अब देखो. If you are interested, then I can arrange what one session, more session, because already it is a 2.5 hour. Just I want to give what 1 or 2 assignments, right? And we will arrange one session just before the gate exam. Just quick revision. If you want, then please give me the comments, right? हाँ, 1 minute. वो मैं आपको बता दूं जरा, मैं थोड़ा हिंट कर देता हूँ. वो जो क्वेश्चन है ना ऐसा, right. So obtain the Norton's equivalent at the terminal A and B of the circuit. If you want the Norton's equivalent, always remember Norton's equivalent means one current source, that is called short circuit current IN, and one resistor or impedance in parallel. This is called RN. This is called Norton's equivalent across A and B. This is the A, this is the B point, this is the 50 kilo ohm, right? This is the VAB, 80I, that is the value, 8 kilo ohm, this is the 0.001 VAB, and this is the 2 volt. Okay, right. Now one thing extra, that is one question asked, I think this type of question. If this is given, I think that is the resistor and inductor. This is the V. Okay, now watch this. V means what? Resultant means what? The current will remain same. This is the current. Try to understand this concept. Okay, current, because in series the current will remain same, we can make a diagram. So reading of this voltage is given, V1 is given and V2 is given. Okay, no problem. Right, first of all watch this diagram. For this diagram, the current I, it is in series. Let I am giving the 0 angle to the current. This is the I, that this is the 0 degree, this is the 90 degree, and this is what 100 degree. This is minus 90 degree. Minus 90 degree. That is the current. The voltage across R2 will be in the same phase. Voltage across R2 will be in the same phase. Right? We can write like this. And just I am going to give you the hint only. This is the VR. This is VR. Everyone try to understand this. Now, this is the voltage across the inductor. Voltage across the inductor. Okay. Inductor. That is the resultant of this. This is called what? V. That value is given to you. That is what V2. That is what V2. What is the V2 here? V2 is nothing but root over VL plus what? VR2. Right? VL square plus VR2 square. That is the phasor sum. This is the value of what? V2. Now, what is the V1? Right? If that is the current, try to understand. That is the current. Right? If it is in the same phase, means what? Again, once you will get the value of the V2, then watch this diagram. Or you can find also the angle of this. What is the V1? V1 is the current through this branch. Why? Because the same current will flow. The phase difference between I and V1 will be 0. So this is the V1. Now this is the value of what? V2. If you have the idea about the phasor, then you can find the resultant, and resultant is also given. Then if the resultant is given, then you can find the angle also. This resultant is given in the question. That is the value of what? V. That is the value of V. This V2 is given, this V1 is given, this V is given. Right? If three things is given and you have the formula, then you can find the value of this theta. And this is nothing but angle between what? I and theta, because this is I. And the phase difference between V and I. What phase difference between, if once you have the idea about the V and I, then simply what is the power factor? Cos theta. Where theta is nothing but phase difference between resultant current and applied voltage. Is the case. बनाओ जरा try करो. इसका formula आपको this value is given, this value is given, and that is the resultant is also given. Then you can find the value of the theta also. You have one standard formula. Use that formula. Try to solve this question. S Kumar, now it is clear. You are getting some hint. यार hint काफी है. बनाओ बड़ा question. Right? No. Finally, that you have to deal with this diagram. You have to deal with this diagram. Right? If I am knowing parallelogram method, vector summation. Right? Vector. Right? So yeah. This is the diagram, that is the diagram, and then use this one. Okay. If you have the idea about the angle, then you can find the resultant. If you are not having the idea about, you have the value of this, this and this, then you can find the angle. And that, remember that current is what? Current and V1 are in the same phase. You can get the value of V and I. So that is the hint, that is the, okay. But voltage across that L and R2 is also given now. I will go through that question because I have just simply watched the diagram. So that is the hint, no problem. I will provide you the solution in the Telegram channel. So this is the one. Second, last one. You will get the question from what? Dot convention. Right? You will get the question from what? Dot convention. 1 minute. That is not the question. If this is the case, everyone tell me what is the L equivalent for this diagram. This is the 2 Henry, this is the 3 Henry, and the mutual inductance between these two, M is equal to 5 Henry. Yes, please. What is the L equivalent for this diagram? L equivalent for this diagram. Okay. What will be the answer? Now I will arrange what second part of that. Within second part, you will get the. I will provide you the concept of what two-port network, and one important thing, that is study state analysis of what? Sinusoidal signal. Study state analysis of sinusoidal signal. So that Kumar SKM is giving L equivalent is equal to what? 2 Henry. Yes, this is a series opposing. What is the L equivalent? L1 plus L2 minus 2M. 2 plus 3 minus what? 2 into 1.5, that is the 2 Henry. That is the answer for this question. Okay, so 2 Henry. This is called series opposing connection. Similarly, when this is the dot or this is the dot, current enter through the dot, enter through the dot, current leaving the dot, leaving the dot. Right here the current enter through the dot, but for this it is leaving. That's why we are using the negative sign. But here in both the case, if it is M, if it is M, the L equivalent will become L1 plus L2 plus what? 2M. L1 plus L2 plus 2M. Now more questions on this. अगर आपने सेशन को अच्छा लगा तो आप प्लीज एक बार लाइक बटन प्रेस कर दीजिएगा. Right, in next session we will discuss again. I will arrange one second part for that. That is a series tricks to handle what? MCQ in gate, strategy to maximize your marks. Okay, 27th on 8 p.m. 27th on 8 p.m. and that is a subscribe that channel, press the like button, share the link of this session. That is the BYJU'S exam prep, ESE and gate, a complete solution to all your gate problems. Okay, yes Dheer. Okay then, तो धीर सर मेरा क्वेश्चन एक बार आंसर कर दीजिए. चार्ज मतलब अक्रॉस आर ना, वाई? नो 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 नो, लॉस कैसे? एनर्जी लॉस होगी धीर, एनर्जी विल बी लॉस्ट, राइट? Initial energy across, you can calculate the energy. That is the means by which we are changing the value of what? Energy, right? Now in series the charge will remain same, right? Because of that there will be a flow of energy, but initial energy across the capacitor is more, final energy across the capacitor will be less, because the energy will be lost across what? Resistor R. You can calculate what is the initial energy E1 0, E2 0, and what is the final energy E1 infinite, E2 infinite. Take the difference of that and calculate the power dissipation across the resistor and find the energy. That will give the answer. Okay, ये है, and that energy will be lost. That question, it is not the case. It is not the case. Plus what? Energy lost across the resistor. Energy lost across what? Resistor. You can calculate, this is nothing but half of C1 V1 0 square, half of C2 V2 0 square is equal to half of C1 V1 infinite, half of C2 V2 infinite. And what is the lost energy? Just I am giving you the formula. You have to calculate the power. What is the power? I square T into R. You have the value e raised to power minus 3T square What is the value of the R? 1 ohm. Integrate it p dt from what? 0 to infinite. This is the loss, energy loss across the resistor. So yes, p square I square R, integrate it, e raised to power minus 60, right, dt, 60 square dt. Okay. Formula. Use this formula and integrate it. Square करना है, that is the e raised to power minus 3t the square, and that is what? Into what? 1. E raised to power minus 3t into e raised to power minus 3t is what? E raised to power minus 60. E raised to power minus 60. That 2 will be multiplied. It will become e raised to power minus 6t. Now I think everything is clear. Okay. Okay then. So please like the session, subscribe, and you are on BYJU'S exam prep. You can download this app. Thank you and good night and good luck for coming exams. Thank you.